Well, good morning, everybody, and thank you for attending this second morning of our webinar where we have partnered with our friends at the Association of Drilled Shaft Contractors, International Association of Foundation Drilling, for more education coming your way. And this is Craig Hamlin with Oregon OSHA, along with my colleague, Mr. Chris Gillette. We are both representing staff education here at Oregon OSHA and have been fortunate to have met and work with Rick Marshall, the safety director at the association, among others, such as Becky Patterson, the chapter administrator here for the West Coast chapter of the association. And mentioned yesterday, back in 2017, Oregon OSHA and the Association of Drilled Shaft Contractors, the West Coast chapter, established an alliance to provide training and outreach and to not only, of course, help ADSC, IAFD members and other construction contractors here in the area, but also OSHA staff so we can learn more of the insights and perspective and gain all that knowledge from the folks that are in the industry. So we do appreciate our partnership with the West Coast chapter of the Association of Drilled Shaft Contractors. We were just talking just before we started the webinar, and I'll never forget Mr. Rick Marshall's first, well, I don't know if it was your first visit to Portland. Seems like you were out here, you had already been out here, Rick, prior to January 10th, 2017. And Rick and Becky and a few others who were helping with some planned training there that was going to be on January 11th, 2017. Well, they arrived here at our office in Tigard, Oregon the afternoon before, so June 10th, and we had, or I'm sorry, January 10th, and we had a slight forecast for snow. And for those of you that live out here in the Pacific Northwest, if there's a forecast for a half-inch of snow, the light rail begins to shut down. The chains are installed on the tires, and we're facing Armageddon. The water and the bread and the milk is sold out already at the grocery stores because we just can't handle a half-inch of snow. Well, come January 11th, or overnight, January 10th, January 11th, it was Snowmageddon. And little did I know that when I saw and met Rick for the first time that afternoon on January 10th, that would be the last time I saw him that January, as they then needed that entire day on January 11th simply to get back to the airport to make their evening flight. And Rick, if memory serves, I think you guys were stranded at the bottom of the Markham Bridge for about 3 or 4 hours.
Oh yeah, it was an interesting sightseeing 1 inch at a time of Portland, Oregon.
So thankfully they were amenable, and we brought them out a few months later, and we accomplished that important training. So again, thanks for this alliance, Rick and Becky and others. We truly appreciate it, and certainly more to come. Now, these 2 morning webinars are recorded, and we will post those and make those available along with all of the slideshows that you have seen both yesterday morning and if you do have any questions throughout the morning presentation here, which will be primarily Rick, along with a few of us here at Oregon OSHA to finish the morning, please submit your question in the chat, and Chris and I will do our darndest to monitor the chat and ask those questions that come in. So again, thank you all for your attendance this morning. And without any further ado, Mr. Rick Marshall from Cincinnati, Ohio, Safety Director of the Association. Thank you, Rick.
Good morning, everybody. Thank you, Craig. Appreciate it. We were supposed to talk about this topic yesterday, but I ran long, so we're going to kind of cram it in today. Some of you, Matt Jennings alluded to it yesterday within their company that they have some certified foundation drill rig operators on staff. So we wanted to discuss a little bit about foundation equipment certification. It was one of the topics that some of you suggested we have a conversation about. So we'll just jump right in and do to it. The National Commission for the Certification of Crane Operators is a nationally recognized entity. They are an accredited certification system. So that's why we're talking about it. And so I'm not knocking any other certification body, but these are the people ADSC has partnered with, so they're the ones I'm the most familiar with. There's three basic pieces of equipment in the deep foundation industry that are require, or two of them have operator certification requirements, and one is a voluntary certification. Those are mobile cranes, dedicated pile drivers, and foundation drill rigs. So we're going to talk a little bit about those this morning. Hopefully you're familiar with, this is the federal OSHA standard. This is in the scope subpart CC, as it goes through and lists out every piece of equipment that OSHA has defined as a crane. And you'll notice the term that I've highlighted, dedicated pile drivers. In OSHA speak, a dedicated pile driver is a crane. However, there's no actual, there was at the time this was written, so this standard was written and came out in 2010. There was no definitive certification for a dedicated pile driver. So as we fast forward, one has recently been developed. Some of you are thinking, because of the term pile driver, that we're talking about a mobile crane with a pile driving attachment. And there's a difference there. So I wanted to make sure that we were clear on the differences of the two pieces of equipment. So, and again, in subpart CC and some of the definitions, the term attachment. So this is referring to a mobile crane, but it may have, in our case, an auger or a drill or pile driving equipment. So to look at it, these images here are, this is a lattice boom crawler crane, as this one is. This one has what's called fixed leads. So they're physically attached to the boom here, and also down here on the spotter. Same with here, this is the spotter. This is a physical attachment. So this is a mobile crane with an attachment. These are different types of mobile cranes. So this is telescopic boom crawler. It has so these are fixed leads. These are suspended or hanging leads, depends on where you're from and your terminology that you use. So this is freely suspended from the crane's hoist lines. These are the pile leads, and this one has a pile driver in it. This one on a lattice boom crawler has leads, but this one has a drill in it. So these are four different pieces of equipment, but they're all mobile cranes. So the person sitting in the seat needs a mobile crane certification for the type of machine this is. OSHA directly speaks to a dedicated pile driver. So in the operator certification program, at the time of the rule was passed, there was no such thing as a dedicated pile driver certification per se. As the industry started chiming in on what should and shouldn't be, it was discovered that it would be somewhat inferior for an operator of a lattice boom or a telescopic boom crane to have a certification to run a dedicated pile driver, because they have some similarities, but they are really distinctly different machines, as we'll see here in a minute. So they're very specialized. So this is what a dedicated pile driver looks like. And in OSHA speak, it's a machine that's designed to function exclusively as a pile driver. So all this machine is designed to do is to, in this case, drive, this is an H-beam section, has a vibratory hammer. Could be an impact hammer, I can't see because of the way the picture is oriented. But that's what physically, so there's some similarities, but there's some differences. So all this does is to hoist the material and pile driven, physically drive this beam, as you see here, into the ground. That's a dedicated pile driver. They look similar, but there's some differences. Most of them are built in Europe, either in Germany or in Italy. So you have a vibratory hammer here. This is a much larger vibratory hammer. These are driving individual piles. This may be some sheet piles with interlocking H piles. All different variations of the same thing. But there's a true difference between a mobile crane with an attachment and a machine that's called a dedicated pile driver. So here we're driving sheet piles. This is driving a reinforced precast concrete pile. Similar machines, different from a mobile crane. So we have a similar association out there. It's called the Pile Driving Contractors Association. They teamed up with the N3CO to develop a new certification specifically for a dedicated pile driver. That certification became available in 2016. So you all know as compliance officers that they're now throughout the country is a requirement for an operator of a mobile crane to be certified for that type of machine, okay? So you now can be on the lookout if you see a dedicated pile driver in your area. They're not terribly common on the West Coast, they're more common on the East Coast, but if you see a dedicated pile driver, the person in the seat should have, or shall have, in your terms, a certification for a dedicated pile driver. So ADSC, thinking that knowing in advance that certification for this type of machine was going to take place, we opted as an association to get ahead of OSHA in this case and create our own certification for a foundation drill rig. So internally, we had numerous conversations. We decided as an entity to create a task force. Of course, that's what we're famous for in ADSC, is to create a task force to decide what we should and shouldn't do, and to satisfy this particular need. One of the things that triggered this task force was, unfortunately, in the province of Ontario, if you were tuned in yesterday, I spoke a little bit about working platforms, and one of the triggers that caused a working platform requirement in the province of Ontario was this particular incident that took place in 2010. A very large foundation drill rig hit a soft spot in the ground, it rolled over. If you can see my cursor, this is the mass of the equipment. It totaled this machine. It did so much damage to this machine that it totaled it. But unfortunately, underneath the mast here, right where these firefighters are, was a young man who was crushed running a small rubber-tired backhoe. So this incident, this fatal accident, triggered in the province of Ontario that the operator of a foundation drill rig has to have some type of certification. So here back in the States, as history pointed out, we would be, as a contractor, when we showed up on a job site, someone from the owner or general contractor was probably going to ask to see some kind of documentation that the person running the drill rig had some kind of training, some type of authorization to operate it, what their skill level was, what their experience was. And the typical response was from a contractor to write a letter on company letterhead saying that our operator has X number of years operating this type of rotary foundation drill, and maybe list out a couple of the more recent projects. And that was pretty much taken for granted as good to go, so to speak. However, times have changed, we've advanced, and more owner, general contractor are asking more intricate questions. They want to know more, they want to have more documentation, they want to see records of training and whatnot. So this is one of the things that triggered our association to get ahead of the curve and create our own internal certification. Well, it sounds like a great idea to become a certifying body. However, there's a lot more to it than just putting your name on a piece of paper and putting a stamp on it. We consider ourselves to be proactive, and we're good at what we do, and we have a great working relationship with OSHA from a long history of working with them. So we decided, sure, we can do that because we're contractors basically, and we can pretty much do anything. Our motto is, we've done so much with so little for so long, we can do the impossible with nothing. We decided to send someone to an ANSI certification training class because that would be the right thing to do. And when that gentleman came back, we quickly learned that in no way, shape, or form could the ADSC be prepared or even take on such a task as becoming a certification body. So we couldn't do it financially. We don't have enough staff. So we found that that would be pretty much a terrible thing to do. So what did we do? We did the next best thing. We teamed up with the National Commission for the Certification of Crane Operators. We signed a contractual agreement with them in February 2017. And by December of 2018, we had a certification program up and running. Certification is interesting. A lot of people have different ideas of what the process actually entails. So I thought I'd quickly explain it. So in this little bar graph here, the first thing you need to do is educate the operator. This goes for any type of machine. It doesn't necessarily talk about foundation drill rig operators. Once you educate the operator on the safe operation of the type of machine that they are going to be operating, you can then get that person certified. Remember, the certification is only for the safe operation of that piece of equipment. It has nothing to do with what the machine's intended use is going to be. So in order to do that, you have to make sure that the examination process for the certification is indeed accredited. When you work with N3CO, their programs are accredited. They have to be observed and audited every 5 years to make sure their programs are meeting the goals. Once you become certified, you then have to train the operator to operate the piece of equipment that you're going to assign them to. Once they have the proper training, you then as an employer need to qualify that and announce to the world, so to speak, both externally and internally, that you have qualified this individual to operate that type of equipment. And then piggybacking on the OSHA crane standard, we feel you must also evaluate the operator to make sure that he or she can actually perform safe operation of the machine assigned and also perform the tasks that you ask them to perform. So in the education, it could be schooling, both in theory and in practice. Ideally, the operator learns definitions, processes from either an instructor or a mentor. There's course material available and the opportunity to practice what they've learned in the classroom on an actual piece of equipment. Certification would occur after the individual receives appropriate education, as I said. That education could come from a trade union, could come from a trade association such as us, or it could be some other educational institution. There's a few here in the United States. Certification, one that gets from N3CO, demonstrates that the candidate's skills have knowledge of the subject, has skills and knowledge that subject matter experts have deemed necessary for the safe performance of a given type of equipment. So the certification process was written by safety people, contractors, subject matter experts in the field of, in this case, deep foundation industry. NCCO certification is, like I said, is in no way testing or certifying the operator's proficiency to install a given product. So for an example, a tieback anchor or a drilled shaft. It's the certification is of the candidate's ability to recognize the safe operational procedures and then safely perform those basic maneuvers inherent, in this case, to both large and small foundation drill rigs. Remember, it's not a certification of how to install a product. Accredited, ANSI has a very rigorous accreditation requirement. Again, that's why we teamed up with N3CO. There's no way an association like ADSC can even begin to meet those requirements. Training, ADSC provides training. A contractor can provide training. Once you pass the certification exam and you understand the processes, but you need to be trained on how to operate the specific machine that you're going to be assigned to. They're similar in nature, but oftentimes they have different functions. The controls may be slightly different. The triggers, the levers, the computer systems, they're not all the same. So one has to be trained on each individual piece of equipment. Then the contractor should qualify that particular individual on performing not only operating the machine safely, but the tasks that you're going to ask them to do. This means the operator can differentiate. So the more qualifications that an individual can get, the more valuable they become to the contractor or the employer. And as I said earlier, based on the crane standard, we feel as a trade association that our members should also evaluate their operators if they're certified in foundation drill rig operation. So this is a snapshot early in the exam process, developing the practical exam over here for large foundation drill rig. This is the one for the anchor micropile type drill rig. Again, they're not really drilling a hole, they're not drilling an anchor or tieback. However, they have to maneuver the mast and engage drill steel at different angles. This type of machine has to engage, swing around, and demonstrate that the operator has proficiency in operating the machine at different radiuses and understanding what the machine can, and more importantly, what the machine cannot do. This is a snapshot of a dedicated pile driver. Since they are cranes, they do lift things. So this is lifting a pile. You have to put it up underneath the hammer. So it's a fairly involved practical exam for each. This is an example of what the written exams cover. I'm not going to dwell on them too much. But so you know that N3CO has a code of ethics. They have all these items here that a certified operator has to comply with. And do they police and check it? Most of it is on the honor system, but if someone files a complaint against an individual, N3CO, because of their code of ethics, they will respond and they will investigate to make sure that either the claims are proven false, or if they are true, then they may ultimately remove that person's certification. Requirements. So each of the certifications that N3CO has have a 5-year lifespan. So the Foundation Drill Rig Operator certification is likewise. So you can recertify 12 months up into that time. You have to continue to meet medical requirements, follow the substance abuse policy, comply with the code of ethics, and you must pass both the written and you have to pass the written to recertify. You don't have to pass the, you don't have to take the practical unless you blow out of your 12-month window. So, for example, we are in the process right now. I'm on task force. We have to continually write questions because the test questions, there's, I don't know, like 120 questions. I can't remember. Sometimes when more and more people keep taking the test, more and more people talk about the questions. So we have to either change up the questions or actually add new questions to make sure we're testing people's knowledge and not just a repeat of what someone else told them. A contractor can set up a test site in their own yard to do this type of practical exams if they want to, but there's an awful lot of criteria that you must comply with to make sure that N3CO and their ANSI accreditation is met. Practical examiners can be, so N3CO doesn't have practical examiners on staff. They all are volunteers. Some do their services for free, some charge for their services. The ADSC West Coast chapter has a person on staff, if you will, that can perform Foundation Drill Rig Operator certification. They are having, I believe, a practical exam coming up at the end of the month in Salt Lake City, Utah. So we're progressing. We haven't, COVID obviously put a damper on a lot of things that we wanted to do. So there's approximately 150 thereabouts certified Foundation Drill Rig operators in North America. There's, I think, 2 in Canada and the rest are here in the States. A candidate gets a reference manual from N3CO. This one's for dedicated power divers. This one's for Foundation Drill Rigs. And we, as an association, develop reference manuals that have a lot more information about a large variety of Foundation Drill Rigs, both large and small diameter machines that a candidate can access. These reference manuals are on the ADSC website. So as a OSHA compliance or consultation person, you can access that information. I'll send the links to Craig, and you can kind of get a better understanding of how the machines operate, what they can, what they cannot do. So if you encounter one on a job site, you perhaps will have a better understanding of what exactly you're looking at. So that's the quick down and dirty on operator certification. If you want to move on, I will, or if you have questions.
Yeah, Rick, we got a question. You want to cover it, Craig, or do you want me to do it?
I got it right there.
Is there any grandfather clause in this requirement for seasoned operators, or did companies have to go back and have a veteran go through the process?
No grandfathering. You got to start from scratch. If you're 20 minutes in the seat or 20 years in the seat, you got to go from zero.
Great. Thank you, Rick.
That was a question when we first started the process. That was a good question. And we talked about it, but decided to make it fair. There would be no grandfather.
Hey, Rick, while you're transitioning to your next slide deck, I have a bit of wonderful news here. When we come back after our first break, we will have Miss Becky Patterson, the chapter administrator for the West Coast chapter of the association, join us for a few minutes to introduce her.
Cool.
How's that for a tease? I think they call that a tease in this business.
Well, she's much better looking than I am, so that's a good thing. Okay, so next up, we're talking about earth retention systems. Is that right?
Yes, please.
Okay. So here we go. The whole trigger for this entire conversation was because this is a excavation and trenching week in Washington and I think in Oregon. So we sort of want to relate it to that type of hazard that exists in our world. So while you guys typically think of trench boxes and sloping and shoring and whatnot, we don't quite do that in the same way. So we want to kind of describe it. Based on some of the images you saw yesterday, you've seen some of these already. I'm sure you've been in any job sites where they're early on. You may have seen some of these structures already in place or actively being installed. So some of this may not be new to you, but we'll talk about it briefly. Most of you are aware there's some tragedies that take place, and it's interesting that 60% of someone who's injured or killed in a trenching or excavation accident are a rescuer. Could be a civilian, could be a coworker, could be an untrained fire rescue personnel. So it's an unfortunate thing to happen. So it's not always just one individual. Usually sometimes responder number one becomes victim number two. Cave-ins, as everyone hopefully is aware of, can happen without warning. And all fatalities, I think most of you think, could have been prevented had we taken the steps to do so. Are there employer responsibilities? Of course there are. We got to provide training to employees who may be exposed to a hazard associated with trenching or excavation. That's such an easy statement to make, but yet, unfortunately, we don't seem to see a lot of that taking place, especially when you read some of the fatality reports that OSHA, Oregon OSHA, and Washington publishes. We're supposed to, as an employer, educate, train, and then assign a competent person to be on site whenever trenching or excavation operations take place and we have exposure. And the employer has to provide the necessary means, methods, and protections for all employees to safely enter, perform their tasks, and then properly exit the trench or excavation. Some definitions that most of you are familiar with: a man-made cut, cavity, trench, or depression formed by earth removal. So we feel, as a drilled shaft contractor, we're creating an excavation. Okay, even though we backfill it with concrete and now it's a foundation element, it's still excavated material, it's man-made. A trench is a narrow excavation. So hopefully I get it right. So all trenches are excavations, but not all excavations are a trench. And a trench is defined as the depth is greater than the width, but not wider than 15 feet. So there's a caveat there as to whether or not you're in a trench or an excavation. We're going to talk about shoring here because it's one of the protective measures that an employer can use to protect their individual employees from hazards. Shoring can be, and most people think hydraulic or mechanical or timber shoring, but we're going to advance that to another type of methodology. Employers shall protect employees from cave-in by using adequately designed and protective systems. So we're going to show you some variables on what you might not be used to. We're going to talk about earth retention. Earth retention systems are used in a variety of construction projects. They could be temporary. They might be part of a permanent wall. Most of the time they're in a basement for either a smaller or a large building or other type of structure. You've seen them on highways where you have the approach to overpasses. It may be used to stabilize or support a slope or an existing wall, highway abutments, wing walls, embankments, used to support a active landslide. No matter what the application, earth retention systems protect nearby foundations from settlement, stabilize lateral earth pressures, controlling movement, and draining potential groundwater. So in a sense, an earth retention system is a form of engineered shoring, to use OSHA speak. Many different ways that you can create that in our world. We can use sheet piles, soldier beam and lagging. Matt and Dan alluded to that yesterday. Soil nails, shotcrete, bracing, internal and external. There's a CFA or auger cast piles, secant piles, diaphragm, and chemicals. So let's kind of take a quick look. So driven sheet piles, pretty simple. It's a piece of steel. Could be not only steel, but it could be a variety of different materials. Steel is the most common in our world. Driven by, in most cases, a vibratory hammer, mobile cane, a suspended vibratory hammer. This is a dedicated pile driver doing the same thing. These are become more and more popular, as I said earlier, along the East Coast and then along the Gulf Coast. I don't know if you've seen them here or not, but they're coming to a work project near you soon, I'm sure. Finished product. So we have the driven sheet piles. They've excavated out behind here. You can already see the foundations are going in for the structure. So this is holding back the earth. We have some form of anchors system put through here. So they've drilled through the sheet pile wall to anchor it back. This is a two-stage wall. We have the lower and upper levels here. So this is a pretty complicated job site. This is soldier beam and lagging. This particular wall was installed, so they either drilled or drove in. I'll show you a picture here in a minute. These H-pile sections, they're driven or installed so deep, they may be from where you see here, another maybe 10 feet below the surface here is where they're anchored into the ground. So this is what's called a cantilever wall. So the strength of the beams and the wood lagging is holding this earth behind it. So this is a very common, for small projects, this is a very common, inexpensive way to install earth retention. And as we're going through here, you compliance officers need to be thinking about compliance issues here. So if we have a person standing up here, what's the first thing that comes to your mind? Probably fall protection, I would hope. So how do we deal with fall protection? So these are things that you need to be thinking about. How do we access this area? How did they get there? You guys typically look around and you're looking for footprints up there. And when the contractor says, we don't have anybody up there, then you have to ask, how come I see footprints? You guys are sneaky sometimes. This is how you drill in a pile. So this hole has already been pre-drilled by this drill rig here. And they're using a mobile crane to insert this beam into the proper elevation. This hole here in the beam is for a tieback, which will be installed later on. Here you see a drill rig in action. They're getting ready to finish drilling and then set this beam in place. Typically, when the beam is set in place, it's backfilled with either concrete or lean mix is what we call it here in my world. You guys call it consolidated fill in your world. Same kind of stuff. It's very weak concrete. Along the East Coast, a lot of contractors use a micropile drill rig and install large diameter micropiles as earth retention as opposed to an H-beam or an I-beam. Does the same effect. Here we have drilled in elements and we have wooden earth retention installed in place. This at the moment is a fairly simple job, but it's probably going to go another lift or two deeper. So we have an excavation in place. This contractor is driving these H-beams in place. So we have a mobile crane, suspended leads, and they're mechanically driving these piles in place. Why do you do one over the other? Sometimes it's economics. How fast can you get to a job site? What equipment does the contractor have? Some months steel is really expensive, so concrete is the way to go. Other cases, concrete is way higher or I can't get it. It's not readily available, so you might drive piles instead. This is shotcrete. So this gentleman here is actually spraying liquid concrete, for lack of a better description, against a wire mesh reinforcing steel wall. And because of the admixtures and whatnot, this material actually adheres to the mesh and to the soil behind it. And you get an end product that looks like this. Some contractors finish that off for smooth, and there's some really cool contractors that make this look like it was a natural stone wall as opposed to just what you see here. Other times, the owner or general contractor may come by and put up a face wall so you don't see this initial wall here. So lots of involved. I think Matt told you about silica exposure here. So this gentleman has some exposure. But this guy here also has exposure. So this is an older picture before silica, so don't flip out here. This is what we call in our industry a tieback anchor. So we have a foundation drill rig that's now it's drilling a hole through this wall at a given angle, could be 25, 30 degrees, and they will drill down and they will either install a tendon that Matt showed you yesterday and then grout it and extract a drill steel. There's several different ways that you can do it, but when you're finished, you have a tendon that's inserted into the ground. Matt showed you pull tension on it, and then that anchors the wall from tipping over. You'll notice here we have fall protection in place. We actually have an employee up here maybe doing something up here. Dan told you about people cutting holes through fall protection to access or do a job. We have to make sure that we're maintaining this. And then we have to make an agreement that when the earth retention contractor leaves the site, that the owner / general contractor maintains this fall protection, because this might be up for almost the duration of the project. This is what's called an internally braced project. So this is a pretty deep excavation in a downtown urban area. So these braces here act as struts, so the walls are pushing against one another. So you start from the top, you excavate down, the beams are already pre-installed. Contractor installed these ring beams as the excavation was completed. We now have ladder access egress. We have a machine down here working. You probably still have more material to remove out here until they get down to the bottom of the excavation. Some people call them auger cast piles. That's kind of a trade name. They're called CFA, continuous flight auger piles. California has a different term for them. A lot of people have slang terms for them. But essentially, it's a rotating auger that drills to a given depth at a certain diameter. Could be from a mobile crane with suspended leads, or it could be from a dedicated drill rig. Numerous different ways to do that. But this is the end result. So the beauty of this type of installation is, as they're drilling and pouring or pressure grading concrete, as you excavate, the shoring is already in place. You don't have to install it. These beams here are used to further anchor the wall from overturning. So they're getting ready to drill more tieback anchors in this lower beam here. That's why you don't see any. There's such a thing as what we call in our industry a secant wall. So this drill rig has external casing that it advances at the same time that it drills. And then when they backfill each shaft with concrete, they extract the casing and you get this done. Those of you who live in Washington or have ever been in Seattle, this is the emergency access pit for when they took Big Bertha out of the tunnel she was drilling and they had to fix it. So this is the access pit that they created just to get the tool out of the tunnel. So this is what's called a secant wall. So this was a pretty cool picture. Good friend of mine took that, and that was quite the thing. It was on the news and all that good stuff. Somebody from your organization asked about chemical grouting. So chemical grouting is a soil stabilization technique that uses typically, not always, a polyurethane chemical grout injection. So what am I talking about? Think of that like that expanding foam that you put in between your windowsill or a door frame or something like that. It's a product somewhat similar to that, only it's a lot more refined. What it does is it transforms fine granular soils into sandstone monolithic masses. So this tells you right now, it only works in granular soil. If you have hard clay, it won't do a thing. But if you have fine granulated material, gravel, sand type of stuff, this is a technique that you can use. What do? You literally jackhammer a 1/2-inch diameter pipe into the ground in a grid pattern, and then you inject the chemical grout through there. And as you're injecting, you jack the pipes out. So you're pressure injecting this grout. So it looks like voodoo here, but the end result looks like here. So here they're using it to better support this building. So they can chemically grout underneath the building, offer it support. Maybe it was settling, so they did it as a repair, or they use chemical grout to act as earth retention, so they could excavate out here. Maybe they're going to add an addition to this building. Now they can work and do the foundation work. There's a term that we have called jet grouting. This is a method of ground reinforcement that uses a high velocity jet of grout, sand, cement, and water. Maybe not always sand, but definitely cement and water mixture. So what does it look like? Okay, so you have a drill steel. You can see these water jets coming out. So they're in this picture, they're cleaning the jets out with water. But as this is drilling into the ground, grout squirts out under high pressure as it's rotating. And so you get an element that looks something like this, depending on the soil and the soil density. They may be larger than this, they may be smaller than this. But when you do these adjacent to one another, you can get a form of engineered earth retention. There's a product called a diaphragm wall. Some people call it a slurry wall. This is just another methodology to create earth retention in our world. The trencher excavation is initially supported by either bentonite or polymer-based slurry. So all these words say something, but it's better if you see the picture. So here's a typical slurry wall excavation tool. So it looks like a large grab, for lack of a better description. So you excavate a width of we call these a panel. As you begin to excavate so far down, the panel might fall onto itself. So we have a cave-in. So how do you prevent that from happening? Well, you fill the void with this slurry. Could be made out of bentonite, which is a really fine clay material mixed with water, or it could be a polymer. So it's a chemical blend of liquid, water, and the chemicals. And what that does is it creates a stabilizing effect and prevents the hole from caving in. So you're going, okay, well, how do you do that? Well, the weight of the bentonite or polymer mixture and the water together pushes out against the sides. So as long as you keep this full of slurry, you can continue to excavate and it will not cave in because of the weight of the slurry material pushing outwards against the excavated material. Once that's completed and it's to grade, a reinforcing steel panel is inserted. Once that's grade and everybody's happy, you inject concrete into the panel that you just excavated, but you siphon off the slurry mixture because you can clean it and reuse it. And once the concrete is to grade, it will harden. So now this contractor, you can see they've already have some completed here. This contractor may skip 2 or 3 panels and then install another one, and they go around the perimeter of the job site, and now they have a slurry wall for the entire perimeter or wherever they need it to go. Just a different technique for installing earth retention. Like all things that any contractor installs, you have to do it the proper way. You have to inspect it. You have to make sure you're meeting all the requirements as far as the structural design is concerned. And unfortunately, if you make a mistake, do it incorrectly, you do the 3 words that injure, kill, or destroy productivity and quality control in our world. That's hurry, hurry, hurry. You might have a failure. This took place quite a while ago in Washington, D.C. You can see we had a pretty catastrophic failure of a soldier beam tieback lagging. Now, I'm not condemning that process because it's a great process. I put in many of them myself. But unfortunately, the general contractor excavated out underneath the toe or the bottom of the soldier piles here, which caused a domino effect. One beam popped loose, another beam, and all the adjacent ones, and it just dominoed around this corner here, caused a catastrophic failure of the piling wall. So we didn't follow the rules, so to speak. Something everybody knows, excavations are the greatest risks, have asphyxiation due to lack of oxygen. So there could be a lack of oxygen in the excavation, or the weight of the soil is crushing you to the point where you cannot breathe anyway. Could be some toxic materials. There could be a fire inside of the excavation. Moving machinery along the edge of the excavation could cause a collapse because soil vibrates, and I guarantee you, if you give soil a chance to move, it will. Accidental severing of an underground utility. There have been a lot of people who've been killed by drowning because not only did the cave-in crush them, but it also broke a utility line, and then the trench or excavation filled up with whatever liquid was inside the utility line. Earlier, we talked about having a competent person on site. That individual, by OSHA standards, has to be able to determine soil classification, has to understand the use of a protective system, and they better be fully understanding what the entire standard says, just not nitpick the important paragraphs, okay? Most importantly, they have to be capable of identifying a hazard and be authorized to immediately do something about the hazard, okay? A lot of people get the first part, Yep, that's bad, but they may not have the authority to eliminate the hazard. They can't stop the work. They can only tell somebody about it. This may be one of the reasons why people get injured or killed. However, what if the competent person is actually watching unsafe activities take place? That's not a good thing. So if you're a contractor, if you're an employer, you better make sure that your competent person is indeed just that and will not tolerate or allow an environment such as this. Okay, I don't even have to describe how idiotic that is. So we'll just move on. One of the things a competent person has to do or make sure gets done is we have to inspect. So a lot of earth retention contractors that work that are ADSC members are compliant with this requirement, but some are still confused and they say, well, we didn't dig it, so why do I have to inspect it? Well, if you put people in harm's way, if you expose them to the hazard, in this case, an excavation hazard, then you need to inspect it to make sure it's safe for your people to work in it. So ADSC has this form. It's not perfect. It's malleable. You can change it to better suit your needs. But we got to make sure before the shift starts. And if we have an incident take place, we have rain, we have snow, we have high winds or something like that. Water makes the soil wet and gooey. Sunshine dries the water out. So when you evaporate water, it leaves voids in the soil. So you may have a potential collapse, even though it's a beautiful sunshiny day. It's interesting how water can work for you or against you all in the same week. And you can reasonably anticipate whether or not an employee is exposed to hazards by doing what? By inspecting before you put people in the excavation. There could be a hazardous atmosphere in there. Now, if you're working for sewage lines, probably a good fact, but probably if you're doing an excavation in the middle of a cornfield, it may not be. But there are some natural contaminants as well. So if it's deeper than 4 feet and you suspect, obviously you need to check. What some people are worried about, toxic or flammable, but they forget about making sure there's enough oxygen available to actually breathe down there safely. So if in doubt, you check. This guy has a personal monitor. There's many different ways of inspecting the excavation. We have a piece of equipment running here. If it's an internal combustion engine, I can tell the flapper is up, so it's running. It's generating carbon monoxide, so there's a possibility that carbon monoxide may somehow find its way down into the lower elevations of this trench or excavation, conceivably poison the individuals working down there over a period of time. So if in doubt, check. So a question would come up. So here's a typical urban. We're working underneath this overpass. They're maybe going to widen the road, maybe build another bridge, maybe widen the lanes. I'm not sure what's going on here. We have earth retention, but we have people down inside this excavation. We have equipment operating inside this excavation. Did we do an air quality check to make sure we're not, in this case, a carbon monoxide exposure? A question to ask if you're a compliance officer and you roll up on this particular job site. Might question their rigging skills as well. At elevations deeper than 4 feet, you got to have ladder access or some kind of access in and out of the trench or excavation. At 5 feet, you must slope shore or bench, do something to protect the employees. You have to be able to no further than 25 feet to achieve your access or egress point. And if you use a ladder, it has to extend above the lip of the trench or excavation 3 feet and be secured. Most everybody. This is an improper way for access and egress. Okay, it's clever, but not appropriate. Yesterday, we talked a little bit about underground hazards. Since we typically drill into Mother Nature, to find something like this would be somewhat alarming. So make sure you call before you drill in our case. Physically locate prior to drilling. Just because there's marks on the ground doesn't mean they've located every single utility. So as Dan and Matt both mentioned yesterday, it's far better to pothole to make sure you haven't found something that no one knows about. Pretty key elements, proper planning. Okay, if you don't plan, then you fail. If you fail to plan, then you plan for failure, so to speak. Call before you drill. Pothole. Should have a site-specific hazard analysis to make sure you've covered your bases. And you better make sure you have an emergency action plan should you damage a utility. Oftentimes people do all of those, but fail to have the phone number for the gas company, electric company, the water company. They don't have those numbers posted in their job site trailers. So it's a good idea to have them. Calling back 811 isn't going to be a very fast response. Hopefully everyone is listening understands the weight of soil. If you have a cubic foot of soil, so you have 3 feet by 3 feet by 3 feet, that can weigh 2,700 pounds, depending on the density and the water content of the material. So let's just say 3,000 pounds. That's a significant amount of weight in a block of soil. A skid steer with a 1 cubic yard bucket, if you filled it up and dumped it out on the ground and showed a typical field person, they would scoff at you telling them that pile of dirt weighs 3,000 pounds. But if you showed them a small pickup truck, they would say, oh yeah, I believe it weighs 3,000. It's the same thing. So which one would you like on your chest? The pickup truck or the pile of dirt? Well, hopefully they say neither. So somewhere in the neighborhood between 3 and 5 cubic yards of soil bailing off the wall and hitting you and striking you in the back could weigh somewhere between 8,000 to 14,000 pounds of material. Pretty bad for you, unfortunately. What does this weight of soil do to a human being? Well, this person was literally crushed to death. And if you look at this piece of equipment, you see the crawlers of this small excavator. So he's not buried very deep, but yet the force of the material striking him shoved him up against the crawlers here and literally crushed this young man. So I'm sorry it's early in the morning to show you a fatality, but that's the power of moving earth in a small confined area. And people who think they're going to be fast enough to get away from it, they're only fooling themselves. I'm going to try to show you this video. You got to pay attention to it. See this person right here? I hope you can see my cursor. He's standing inside. This is out on Long Island, New York. This contractor is excavating for a septic system in the front yard of a residential home. There's a crane sitting in the driveway that has a clamshell bucket that they're using to excavate. They've already placed 2 rings of the septic tank, and they're getting ready to set a 3rd one. So as they excavate, these rings fall down into the earth and then they keep stacking it. But as they pull this bucket out, watch this gentleman right here. It happens very fast. So how long does it take for a cave-in to take place? Well, you just saw one. You saw someone die. So I'll show you again. Luckily, that gentleman had the wherewithal to grab onto the clamshell, and he was pulled out. It took not minutes, not hours, but most of the day. They worked well into the night to recover that individual that was buried. So unbelievable. So when people ask, well, how fast does it happen? Well, literally in the blink of an eye. If you're installing earth retention like we've been showing you, a lot of people are right up next to it. They have to be here. So they're physically installing these boards. They're manhandling them. They have to get right up against it. But in some sandy soils around the country, oftentimes the material, just under its own sheer weight, boils out from underneath the earth retention. So this is pretty stiff clay here. This is just another example. So while we claim that we can excavate 5 feet at a time to be within the standard, sometimes Mother Nature won't allow that. You may only be able to go down the depth of one board because you have to control this. Okay. So we know this about engineering shoring. We have to have what's called tabulated data, how to put in whales and whatnot. So the tabulated data for an earth retention project should be on the contractor's, whatever they call them, engineer drawings, shop drawings. There should be information on site indicating how the wall was designed, how it should be installed, what angles, how all the tiebacks in this case, the type of wood, the material, the thickness, all that should be clearly identified and on site so anyone can figure out how to install this and do it correctly and have it be safe to protect employees. Contractors have to be aware of working up close to an existing building. You could easily undermine the material out from underneath this building and cause a collapse, as shown in this picture here. So you have to be extraordinarily careful. Over excavating and leaving it exposed over the weekend caused this collapse. This is a school. On Friday, there were children right here. Saturday, they excavated, left it alone. Saturday afternoon, after a small rainstorm, the building collapsed. So it's easy to have a failure if you're not paying attention. We try to limit in our world excavations to only 5 feet in depth. So how do you know you're 5 feet deep? If you're a compliance officer, most everybody I've ever met at a construction site is at least 5 feet tall. So if there's boards over the person's head that are working there, it's probably deeper than 5 feet. So that's a trigger. It's what I use all the time. And I question people, how tall are you? Oh, 6 foot. Okay, so you have dug too deep. Oftentimes there's existing utilities that you have to prepare and take care of. So this one is properly supported. This is a natural gas line, so we have to make sure we are extra protective of that. We have to be very careful. As I said, you give soil a chance to move and it will. So the excavation process underneath causes the material to boil out from behind the lagging boards. So if you're not continually backfilling this and making sure you have what we call intimate contact between the soil and the lagging board, you may cause the structure, in this case, to settle. That's not good. Most contractors I know are not in the business of purchasing real estate they don't want. There's other forms of engineered shoring. This is a hand excavated pit inside of a football stadium. This contractor excavated and then installed the wooden lagging as they excavated down. They treated this as a confined space. So not only do they do the confined space entry training, they also had air quality monitors. They had a rescue crane here. So this is davit bolted to it. So this not only served as fall protection because it was a retractable, but you could also hand crank someone out in the event that they were unconscious and were unable to climb out themselves. This is what's called an underpinning pit. This is a finished product. I'm not sure how popular this is on the West Coast. This is a form of earth retention. So you literally hand excavate out from underneath the building and you pour a block of concrete. You skip 1 or 2 and you do it again until you have everything covered here. So someone is down inside of this pit. It could be 10 feet deep. I've been in one that was 35 feet deep. And you hand excavate, hand pull out the material. This is an older picture, so you don't see any fall protection. I get that. You guys are all screaming, but this is the process. We've improved how we do that. We treat it as a confined space now. So you see we now have fall protection. We have, in this case, this gentleman is wearing a respirator because he's possibly chipping out rock down there. So we want to make sure that he's not exposing himself to anything foreign, particularly silica-laden material. That job I told you about at the football stadium, when I worked for a contractor, we called Cincinnati Fire Rescue. They came out to the site and they practiced rescuing people from underneath this is the seats for the football stadium. So we had them come out there. So we made it a point to have fire rescue come to the job site and explain to them what we were doing, how we were doing it. So in the event, we actually called 911 for them to trigger and do in this case, a confined space rescue. They were prepared to do that. I strongly recommend those of you who are listening that you do that for every excavation and drilled shaft project that you do, because you never know when you're going to need help. And when they come, they need to know what to do. I'm not going to read all these to you, but since you're getting a copy of the slides, these are things as a compliance officer I just quickly whipped out that you should be paying attention to make sure that the excavation or the deep foundation contractor is adhering to. I'm pretty confident you're going to find everyone is doing this, especially if they're an ADSC member. But there's many things that you guys can check and make sure, and hopefully when you're finishing your inspection, you have no dings to report, but you walk off and compliment the contractor on how well they did. So that a friend of mine made this comment in the book that he wrote, Trapped Under the Sea. The more people do something without suffering a bad outcome, the harder it becomes for them to remain aware of the risks that are associated with that behavior. So I'm just warning everybody to never get comfortable with a trench or excavation, because it literally can turn around and kill you. So that ends that particular portion of the program, Mr. Craig.
Rick, you are a master at what you do. I hope you realize that most certainly. I do have one question here in the queue. Are there any special requirements when these retaining systems are installed and then there is a penetration of water through the retaining systems? We have seen construction sites near our big downtown river, the Willamette. Some will refer to it as the Willamette, but we have seen construction sites near our downtown river. They have excavated for the parking garage for the basement of a condo building, for example, and then in a few days, the space is filled with water. Should we be asking for additional information or considerations when this is observed regarding the engineering of these systems?
Yeah, water is not the friend of an earth retention contractor. It can definitely destroy the material that they've installed yesterday. Water erosion can take it out. I've seen it happen. So the technique used for the earth retention system should have been designed to take into consideration the possibility of water infiltrating from the river, from trapped water that's in the ground already, from utility lines that may be leaking. There's all different ways of encountering groundwater. Kind of obvious if you're digging a giant hole next to a river that you're probably going to get some trickling effect in there. So extra caution should be observed. And definitely you should ask that question.
That was by our old office, wasn't it, Craig?
That we had one occasion down there, that's for sure. That's what I was thinking when I was reading your question. That was where I first went. Absolutely. All righty. Well, Rick, you are not only a master of knowledge in this subject area, but also a master in keeping us on schedule. My goodness, I have 9:30 pretty much right on the nose. So let's go ahead and take a break. We will reconvene at 9:45, and we will be joined by Miss Becky Patterson, the chapter administrator of the association. Then Rick will continue on after we all meet and hear from Becky Patterson. So 9:45, everybody. Thank you. Alrighty, welcome back, everybody, to our second morning of this two straight morning webinar with our friends at the Association of Drilled Shaft Contractors. And as I teased you in the first hour, we are now joined by Miss Becky Patterson, who is the chapter administrator for the West Coast chapter of the association. Miss Becky Patterson, everyone.
Thank you. Thanks. Good morning, everybody. Just on behalf of the chapter, thanks so much to Craig and Michael Woods and everyone for putting this together. We appreciate the alliance. We appreciate the opportunity to have this dialogue. And again, on behalf of our members, we really welcome this opportunity to familiarize your inspectors with our industry, our equipment, and our practices. In particular, this is good for all of us. I also, Craig, a handful of our guys have asked if we can have access to these recordings too. So it's something that I'd like to put a link to on our website for our resources page, if you could please. And then also really want to thank Rick Marshall. I am amazed at your passion and dedication to safety, to this industry. I don't know where we'd be without you, Rick. So I appreciate that. And appreciate you taking the time and the effort to put all of this together for us, because technically, you know, he kind of works for ADSC and we're just this little chapter, but he helps us a bunch and it's greatly appreciated. Also, a shout out to Dan and Dan Crawford and Matt Jannings for their work yesterday. They were, Matt was especially nervous and worried, but I thought they did a great job. I was proud of both of them. And yeah, look forward to more of this kind of cooperation and maybe in person again sometime soon. We won't bring Rick Marshall back out in January, February, though. I'm not playing the Snowmageddon game thing. And by the way, it was 18 inches of snow in downtown Portland, you guys. It's not like it was an insignificant snowfall. Anyway, that's all I've got. Thanks for the opportunity.
Well, thank you, Becky. And I did kind of gloss over that fact, didn't I? It was, and being a Michigan man and growing up in Michigan, it was quite a snowfall. I mean, we literally were shut down, and we had good reason to be shut down for a handful of days. I've never seen anything like it, with the vehicles off to the side and the freeway still snow covered 3 days later. It was quite something. So thank you, Becky. Becky Patterson, Timbers and Thorns fan, Miss Becky Patterson, chapter administrator for the association. Appreciate it, Becky, for joining us yesterday and this morning and sharing a few kind words. Much obliged. All right, Mr. Marshall, let me switch you back to presenter, so you can share your screen. By the way, the image that I was just showing, of course, was the signing ceremony here, just a little ways down from where I'm sitting right now with our administrator, and of course Becky sitting right there in the middle, and all three of those folks with big smiles on their faces. All right, there was one question that came in, and it's a difficult question to answer. With the fatality video we watched where the contractor was installing the septic system, it looked like more of a sinkhole than a cave-in. Is there any protective system, Rick, or maybe others that can chime in the audience, that would have prevented that fatality?
Wow. I'm not 100% sure how to answer that. If you had historical knowledge of the area that you were excavating, obviously that might indicate that sinkholes were common in that area. I'm not sure that was the case on this particular area of New York, but to me, it was obvious that they were excavating in really sandy material. This contractor, I would suspect, had done this over and over and over and over and over again. There was willingness, obviously, for the two individuals to jump down inside that excavation and do their thing, so to speak. So I'm pretty sure they were not in any way anticipating that to happen. So I don't have a really good answer for that, other than having historical information that they could have possibly predicted that would happen and then take precautions. And what precautions would have that been? Maybe to pre-grout the area so we wouldn't have that kind of runoff or whatnot. But then think about it, that would have added to the cost of the septic tank installation. So would the homeowner gone for that? Could the contractor afford to do that? Not sure. Unfortunately, in the safety world, we had a fatality, so there is no cost associated with that. It's unlimited. So it's kind of either or. It's a good question. I don't really have a very good answer for you. I apologize. With that, unless there's any more, Craig, I'm going to continue here.
Slight delay here with me hitting the unmute button and then bringing up my camera. Another question that just came in, and obviously we can dip into subpart. Well, we could spend the rest of the time, of course, reviewing our OSHA's excavation standard and visit those rules where employees are prohibited from being in trenches and excavations when shoring systems are installed and removed. This question is kind of around that topic area. In the last video with the cave-in prompted me to remember this question. Do workers really need to be in the excavation when the machinery is operating? Did they need to be there when the crane was moving the bucket? Same thing with workers in the excavation when they are setting the retaining systems, the steel boxes. The employer might state the employees have to be in there to get this job done. And, knowing it's case by case, but generally speaking, are there alternatives? Now, I know, again, subpart P does restrict any employee from being in an excavation when systems or trench when systems are being installed or removed, and when trench shields are being moved vertically, then employees are not allowed to be in a trench. But anything else, Rick, you can share there, just with, the need for workers to be in an excavation, especially more so an excavation rather than a trench, when and even if the employer might differ a little bit and feel the need that employees do need to be in there.
Yeah, if you ask this to 10 people, you're going to get probably 8 different answers. At times, there is a need for an individual to be relatively close to a piece of equipment. However, as we talked about yesterday, then there's the obvious potential of being struck by that piece of equipment, either by if we're talking about an excavator, for example, either by the bucket or by the tail swing of the machine. So if it's avoidable, obviously that's the right thing to do. Did those 2 guys have to be in that pit during the septic tank? Well, the obvious answer is no, because until they were getting ready to set the next piece, they were doing absolutely nothing, unless possibly they were shooting grade, but we can't see that in the video, and I really doubt that they would have to be in there to do that as the crane was excavating. So if in doubt, obviously we keep people away from operating equipment, no matter how good the operator is, because unfortunately we're human and we can make a mistake. There's been too many tragedies that have taken place simply because the operator, for example, opened the door, leaned out to have a conversation, and engaged the control lever, and the machine either traveled or swung left or right, or the dipper bucket opened or closed, and it struck an employee inadvertently. So those kind of things can happen and not even be a part of the excavation process. So to keep away is the prudent thing to do. If you're inside of a trench box, I haven't done too much work in one of those. I personally have never been inside of one. Do you need it? Well, if you're connecting newly installed pieces of pipe or grouting them or leveling the bottom, there may be a need to do that. But you would think that the need for you not to be in there would be enhanced by the fact that we're swinging live loads over your head, we're dumping gravel over your head. Why would you want to be in there? But there may not be a way to get out. A contractor's going to tell you, it takes, you know how long it takes for that guy to climb the ladder, get out, me to put the pipe in, and have him climb back. I now have exposure to fall risks, climbing up a ladder, climbing down a ladder. So there's a lot of ways to explain their way out of things. But until the bad thing happens, all those answers are kind of moot.
And subpart P is very specific in not allowing workers to be in a trench when a shield is being moved vertically. However, of course, many workers are still within a trench shield when it is being pulled horizontally. And back in, I think it was 2006, and there's actually a FACE report that summarizes a fatality investigation that we investigated here in the Portland area, where it was more of a rigging failure. But when they were pulling the trench shield in a tight trench, the hook that was attached to the shovel on the excavator failed, and the wire rope came back and struck the gentleman in the back of his head. So even if an OSHA standard allows a certain practice, but employers or employees deem that practice is hazardous, that's where company policies, of course, can override, a minimum OSHA standard. And obviously, everybody on this call is already in the know that OSHA standards are bare bones minimum standards of minimum standards. So certainly we encourage employers to go above and beyond. Very good. Indeed. And I was looking at statistics not long ago, Rick, when we were talking about the struck by. Obviously, in trenches, by definition, trenches, cave-ins are the number 1 cause of death, but struck by excavator components, number 2, and not to the surprise of many, just because of the proximity that we have in many cases. No further questions.
Good information. Unfortunate results. Okay, we're going to move on to what we call in our industry dedicated drill rigs and mobile cranes, and why they may physically look the same, but they're not. So I showed this picture here because this is part of the practical exam for a dedicated or foundation drill rig. So in this case, we're actually lifting a piece of pipe that the operator, it's a skill test. So you all are looking at me going, well, if it's not a crane, why are you lifting something with it? Well, many manufacturers allow the lifting of some objects. And because it takes place in our industry, we made it a part of the certification process to ensure that the operator has the skills necessary to do that safely. But there are some restrictions and minimums that we have to comply with, and I'll try to explain that. So we have, as an association, a long history of working with OSHA. Way back in 1998, we, as an association, took on the task of recognizing that there is a hazard associated with using a foundation drill rig to lift objects, such as a piece of casing or that pipe that you saw in the skills test, a reinforcing steel cage, or some other object that is associated with the installation of a drilled shaft. So we talked a little bit about lifting all throughout yesterday and a little bit today. So there's obviously dangers associated and hazards associated with doing that process. So we're trying to cover those. We work with many, many drill rig manufacturers to create informational procedures and warning labels. So we actually created warning labels and had language inserted in numerous manufacturers' operators manuals to indicate that a dedicated drill rig is not a crane, but if in fact you lift loads with one, you have to do it within the prescribed methodology that the manufacturer says. We have extremely limited ability for hoisting, and that has to be clearly defined by the manufacturer. So during 2003, remember the subpart CC was put into effect in 2010. So this is kind of gives you an idea of the time frame, how long it took to create. So in 2003, members of ADSC were invited to speak at the CDAC. CDAC is the Crane Derrick Advisory Committee. So we made a presentation, there's a public hearing, to talk about dedicated drill rigs and why we felt that they should be excluded from some part CC requirements, i.e. being defined as a crane. We told the audience that because drill rigs have a limited hoisting capacity, the extremely limited working radius of the suspended load, and the limited ability to do that, and what most people call it as a load chart, they are basically an ineffective piece of equipment to use as a crane. We essentially closed our conversation and our fear would be if OSHA defined a dedicated drill rig as a crane, then that would in turn give license, so to speak, to anyone using one to operate it as a crane and use it far beyond what the manufacturer may say you can or cannot do. So we didn't really want that to happen. So we took on the fact that we wanted OSHA not to define it as a crane, but put in self-imposed restrictions on how to use it safely. So I'm going to try to explain that. First, a little bit about what foundation drill rigs are. So all these machines that I'm going to show you are basically designed to install what we call a drilled shaft. Some people call them drilled piers. Some people call them caissons. They have several different names. But essentially, we auger a hole in whatever diameter that tool is to whatever depth. We extract the material, and then we backfill that cylinder that we just excavated with the concrete and reinforcing steel. This particular machine runs on basically a truck carrier, so it's light enough in weight and short enough in length to operate on public highways without doing very much to it, except maybe taking off this tool as it transports. This machine is a carrier mount, is what we call it, but it is not a crane. Larger machines usually come on crawler tracks. This is on a crawler frame, much like an excavator would be that you all have seen photos of throughout yesterday's and today's presentation. The drill is self-contained. It's independent of the carrier. This indeed also is not a crane, despite the fact that the one previous and this one has what we call an auxiliary hoist line that can lift objects. Now, this is a different animal. This is a crane. So remember earlier I talked about having an attachment. So this is a lattice boom crawler crane, but this piece right here, this yellow piece, is what we call a drill attachment. So this is how it physically attaches to the base of the crane here. This is the engine and the power unit. This black shaft here is what we call a Kelly bar. This is attached to the auger and it fits inside of a rotary, which turns it. It's also suspended from the tip of the boom. It's hard to see the suspension lines. They run from the top of this machine all the way up to the tip of the boom. So this is a suspended attachment used to drill holes. So this is a crane with a drilling attachment. So the person in the seat here has to have in this case, a lattice boom crawler crane certification. Remember, the certification has nothing to do with the installation of the product. So this is a fairly typical dedicated drill rig on crawlers. You have what we call the upper works. We have the undercarriage or base. This is where the tracks are, or the crawlers are. This yellow section right here, we call it the mast. You might sort of call it the boom, but that's incorrect terminology. This is called the Kelly. So this transfers the torque and the rotational speed from this rotary motor to the Kelly bar, which rotates it round and round. And then here you have what we call the cutting tool. In this case, it's an auger. And in this particular frame, it has a auger flights are full of soil material that it just excavated out of the shaft that it is drilling. They come in lots of different configurations. So this one is set up to do drilled shafts. So you see the Kelly bar. Here you see casing installed and additional fall protection to protect people from falling inside the shaft. Here you have what we call CFA, continuous flight auger. This is just a different technique of a foundation element installation, but the basic machine is very similar. This is a dedicated drill rig. This is an excavator mount dedicated drill rig. So you could take this attachment and mount it to several different types of excavator base and still have what we call a dedicated drill rig. So all the requirements to operate this machine are compatible with this type of drill. I showed you a picture. This is a smaller truck mounted one, has the same effect. This is an older style, probably built in the, I don't know, in the mid 60s. This is a newer version of the same thing. So these are still around. They're not quite as popular as these are. However, so there's just different technologies and availabilities and ways and means. It depends on the contractor's needs necessary and how much money they have to spend to either buy or rent this particular type of equipment. You can take the same basic machine and configure it in many different ways. So here's the same basic model, B250. This is machines built by a company called Casa Grande. But yet here we have it in Kelly bar mode. So we have the rotary, we have the Kelly bar. Now we have the same product, but it's now in continuous flight auger mode. So there's many different ways to configure the same type of machine. Yes, or this morning I showed you the jet grouting tool. So here's a larger version of the same thing. They're washing it out as we speak. So you can see the jets of water coming out. This attachment is called a soil cutter wheel. So again, it's on a dedicated drill rig, but a different technology used to install a different product. Some machines have what we call a casing adapter. So it's able, this machine is able with this adapter to not only auger with an auger, but also rotate a piece of casing into the ground at the same time. So what does that do? So that adds stability to the excavated cylinder that we're trying to dig out, so it doesn't cave in. So it's just an alternative method for drilling a shaft. So there's different ways to skin the cat, so to speak, in our industry. Now, any one of those machines has the ability to use, if they're equipped with an auxiliary hoist, to lift objects. Some people use it to lift that casing that I just described that they can attach to the rotary and then install it as they're drilling. Some machines are used to lift a reinforcing steel cage. Okay? So there's several different things that this machine physically can do. The manufacturer indicates what you can do with their machine. Just because it can physically do it doesn't mean you should do it. So part of our argument was to OSHA that the function of the drill rig's mast, so this piece right here, is to contain the rotary and make it so it doesn't do anything but position, keep the rotary and the Kelly bar in a vertical position. It's not to serve as a load positioning or a handling system, much like a crane boom is. The mast length is fixed, while a crane boom, especially if you're talking about a telescopic boom crane, can change their radius in and out quite a bit. A dedicated drill rig has a very limited ability to increase or decrease their working radius. It's very limited. So technically speaking, it's a pretty poor material handling device because of the limitations that it has. Every manufacturer puts in their operator's manual a warning such as this. This happens to be from a Casa Grande, but each manufacturer has similar verbiage that they use to warn you that it has a limited capacity for lifting with your auxiliary hoist. Some expressly forbid you to lift anything other than the cutting tool. Some give you more tolerances as to what you can and can't lift. Depends on the manufacturer. These are the warning signs. So this warning sign right here is what the ADSE task force developed. And you'll find this warning sign in almost every foundation drill rig of the larger size like I've been showing you here. So we're pretty proud of the fact that manufacturers have taken that into consideration and put that inside of the cabs of their machines. This is from a different manufacturer. They tell you this equipment is not a crane. They believe it's important to know that, so they tell you in 3 different languages that it's not a crane. This particular machine was built in Italy. This machine was built here in the United States. The manufacturer is going to tell you, much like you might be familiar with a load chart in a crane, telling you working radiuses, boom length, and whatnot, and what you can and cannot do. These manufacturers of dedicated drill rigs tell you how much you can alter the verticality of the mast. So in this case, if you're going to use the auxiliary hoist to lift something, this manufacturer tells you you cannot have the mast tilt forward greater than 5 degrees, and you can't have it tilt left or right greater than 3 degrees, and you can't have it tilt back any at all. So somewhere between perfectly vertical and 5 degrees forward is the extremely limited amount. If you walked up on a job site and someone told you that the mast angle of my machine was at 5 degrees, you would barely notice the fact that it was not plumb. It's very hard. So there's very limited amount. You can only swing the freely suspended load 15 degrees from the baseline of the machine. Otherwise, you create an instability issue. For this manufacturer, it tells you about mast angle. It tells you that the crawler tracks have to be fully extended, not retracted, and you cannot travel with a suspended load. So that makes this a very poor material handling device as far as instead of using a crane. Again, another warning. This machine is not a crane. This manufacturer tells you that you can lift the tool that goes on the bottom of the Kelly. You can lift casing pipes. You can lift a rope grab or chisel. These are all tools that we use when we excavate a drilled shaft. Okay, some manufacturers are not that forgiving. This is a different manufacturer. This is a German manufacturer. They have a slightly more detailed what you can and cannot do with their machines. But again, they give you a range of where you can take a freely suspended load. They give you mast angles not to exceed. They tell you that the ground and the machine has to be level. The machine has to be level, not just the mast. So again, you have restrictive parameters of what you can do with the auxiliary winch and how much weight it can lift. This manufacturer forbids you to lift anything other than the tool. That's their policy. That's what it says within their manufacturer's guidance. This is a page out of their operator's manual. This is another page out of their operator's manual. Notice it's the same, almost the same identical warning sticker that we created. So they've taken that, not only is it in their machines, but it's also in their operator's manual. So I just discussed about the 5 degrees of verticality, so it's pretty limited. So in this document, I talked briefly about it yesterday. So this is a ANSI standard for the installation of drilled shafts. So this is a document that was written by ADSE membership and safety committee, drilled shaft committee, and associate committee. So we represented all of our technologies. And we created this, so I call it a for us by us type of safety standard for the installation of drilled shafts, but it's specific to our industry. And it says in one of the paragraphs that you must follow the manufacturer's recommendations for assembly, disassembly, inspection, maintenance, and operation shall be followed. So this pretty much echoes what some OSHA requirements do in, say, subpart CC for crane operation. It says the use of the auxiliary winch on a dedicated or self-contained hydraulic machine shall be within the limits established by the equipment manufacturer. So it again echoes the fact that you need to consult the operator's manual to understand what you can and, more importantly, what you cannot do with this particular machine that you're operating. There's not a specific standard that I can remember off the top of my head in federal OSHA that cites that you must follow the manufacturer's recommendations, whatever it says in their operator's manual, but that paragraph has been cited numerous times. It's also going to be used for a general duty clause. So basically, if you have an operator's manual for any piece of equipment, a handheld drill for that matter, and you're not following what the manufacturer tells you to do, it's at a minimum, in my opinion, a general duty clause violation. Drilled shaft equipment operators shall be qualified and authorized by their employers to operate such equipment. I don't know if I mentioned to you when I talked about the NCCO certification that the foundation drill rig certifications are voluntary. They're not mandatory, they're voluntary. Dedicated pile driver, definitely mandatory. So we worded it so it's not a mandatory because at the moment it's still voluntary. Assuming that the manufacturer allows the use of the auxiliary winch for lifting loads, we as ADSE strongly recommend that a lift plan is created. So I think Matt yesterday when he was talking about lifting reinforcing steel cages talked about creating lift plans to do that. Well, we strongly recommend and encourage that if you're using your dedicated drill rig to lift something other than the tool, that the contractor that's doing it creates a lift plan for that physical operation. So what does that mean? So I don't think it's on our website, but I have access to a generic lift plan made specifically for a foundation drill rig. I offer it to people all the time. If someone in the audience wants to see a copy of it, I have no problem. But if you roll up on a site and you see someone using a dedicated drill rig to set soldier piles or lift a cage or do whatever they're doing with it, it might be a question to ask if the manufacturer allows that and what is your policy on doing that. I'm trusting that a prudent ADSE contractor member would already have that information on hand, but hopefully you don't run across it, but I would suggest that you ask the question. Just because we have an exclusion from subpart CC, that's the actual exclusion number for a dedicated drill rig, that doesn't mean we don't have to comply with other requirements. Matt and Dan both talked about fall protection issues around a drilled shaft. We have exposure to pressurized lines on hoses. We have housekeeping issues that Dan talked about. We have training requirements. We have rigging training requirements. We have potential confined space entry and emergency rescue requirements that we have to comply with. So as I said, you have an ANSI document that is clearly published and available to our industry. We talked about it, we created it, we've broadcasted it, that it's out there. Many drill shaft contractors have adopted the entire standard as part of their safety program. So kudos to them for doing that. But they should have awareness that it's out there. So therefore they should be taking, it's an industry standard by by subject matter experts. So the industry should accept the information and then live by it. But failure to have the incorrect or not even have a manual for the operating for the equipment in question, that might be a citable offense. And not following what it says, if it says specifically do not do this in the operator's manual, and then the contractor is doing it, that's a shame on you kind of a situation. So 1926-20 requires you to develop a safety and health program and have frequent regular inspections by a competent person of the job site, materials, and equipment. And 21 talks about training about the hazards that employees might be exposed to. So that's all a part of working around a foundation drill rig. So several conditions. So I'm not going to tell you how to do your job, but I'm just telling you that general duty clause might be something that you might have to use if you see someone using a foundation drill rig inappropriately. We, ADSC, and especially the West Coast chapter, work with trade unions. So they work with, in California, they work with the state of Washington. So we help them provide training. We actually have in the West Coast chapter a drill rig operators training school. That's been quite successful, and they in turn are an established certification body, and they have turned out a few certified foundation drill rig operators within that local. So just to brag on our association, in the if you've ever sat down and read a Federal Register, they're quite entertaining. But if you need to sleep, I would recommend you read it. But in the 2010, August 9, 2010, if you read it, you'll find that a trade association supported the proposed exclusion. So that was what I was trying to explain to you. So we got famous for 15 seconds anyway. So if there's any questions about the difference between a mobile crane and a foundation drill rig, I can take that if you want, or you want to wait to the end, your choice.
Rick, I do not see any questions in the queue, so please carry on, my good friend.
Okay, oops, we'll zoom on here. So to finish up here, you guys asked to talk a little bit about pile driving. So we showed you dedicated pile drivers earlier, so we're going to talk about the process of driving piles, just to make sure. This is an old machine, obviously. Things are a little different back in the olden days. This is actually a steam operated pile driver. So this is a steam impact hammer. Short story, when I was a small child, my father worked for a foundation contractor. He took me out to a project and I sat on the lap of the crane operator as it was driving piles. It was a very cool day for me. That happened a long time ago and I have a very vivid memory. So driving piles. You may have heard of this gentleman. His name is Leonardo da Vinci. He invented a pile driving system that early Romans even incorporated some of his designs and whatnot. So this is a drop hammer. You lift it either using manpower or animal power, lift it up to a certain height and then let it go and it would drop and strike the pile. We evolved into steam. These are steam operated cranes, steam operated pile driving hammers. We advanced now to a more modern style crane. On the back of this crane is an air compressor because this hammer was converted from operating on steam to operating on compressed air. And now we've evolved into what we showed you earlier, a dedicated pile driver. So there's many different mechanisms in place in our deep foundation industry to install a driven pile. There's some regulations that are out there. OSHA has regulations on pile driving. They're pretty old, they're pretty minimal. There's an ANSI standard for driving and extracting piles. And if those of you who ever worked on an Army Corps of Engineers project, the infamous EM 385 1-1 also talks about driving piles. So hopefully everyone in the room is familiar. ANSI standards are not law, but they can be incorporated by reference. There are several incorporations by reference about cranes. B30.5 comes to mind. So it's not uncommon for OSHA to do that. Army Corps of Engineers standard are also not law, but they definitely, you must adhere to them if you're on a Corps of Engineers project. The Pile Driving Contractors Association, which I mentioned earlier, they have what they call a Pile Driving Safety and Environmental Best Practices document. It's available on their website. If you want a link to that, I'll give it to Craig and I'll hook you up with that. Just remind me, Craig, if that's what you want to do. And then there are standards from OSHA, but they're kind of limited and they're very outdated. So you've seen these pictures before, so I'm just going to blow through them here. So this is fixed leads. So the leads, the pile driving leads, are actually attached to the crane at the boom tip, and also what I call a spotter down here at the base of the crane. So we have pretty limited reach or working radius out, but you offer a tremendous amount of control for when you're driving the pile. The operator sitting in the seat now has to be certified as a lattice, in this case, a lattice boom crawler. not for driving the pile, but he's operating a crawler crane. But the operator, just because they're certified, means that they also must be trained on how to operate a crane with all this attachment to it and how to safely drive a pile with all this attached to the lattice boom crawler in this case. This is similar, only instead of being fixed, these are swinging or hanging leads. Again, operator certified for a lattice boom crawler in this case, but trained, educated and trained on how to use this type of equipment. It's pretty tricky to lift. So you see these leads in a vertical position, but at one time they were assembled laying down. So how do you lift them without destroying them? Okay, that's a skill, that's a technique. You need to be educated and trained on how to do that. Hoisting the hammer into the leads, that's a skill. Knowing when to shut the hammer off or when to do this or do that, that's a skill that you have to learn. You just don't get it because you're certified to operate a lattice boom crawler crane. This is a bigger picture of driving with we call this a freely suspended or a flying hammer. So this is attached to a load line on the crane. Again, does the operator, now in this case, this is the power unit for this vibratory hammer. The operator has no control over this unit. Look how far they are apart. So the operator sitting in the seat of this machine has no control whether or not this vibratory hammer is running or not running. So it takes coordination between the ground crew and the crane operator to engage or disengage the vibratory hammer. So again, a lot more education, a lot more training involved in doing something like this. So quickly, a vibratory hammer actually rotates eccentric weights, so that causes the hammer to literally vibrate. When the hammer vibrates, it drives from the weight of the hammer, the sheet pile in this case, into the soil. So these sheet piles here are driven to grade. These are being installed. I won't dwell on how to do that, but it's a technique, believe me. So the complete is usually held by, so we often use a mobile crane to do that, but you'll see more and more that dedicated pile drivers are in use. This one thing that it does do, if the hammer is not inspected and not operating properly, it will cause vibrations to be transmitted from the rigging back to the hoist line, back into the crane. So as compliance, you might want to check to be sure that they're doing pre-shift inspections of not only the hammer and the power unit, but of the crane. Maybe they walk the crane boom to make sure all their fasteners are still in place, because it does do some shit. Some, not all, some older lattice boom crawlers, or maybe, I'm sorry, new style lattice boom crawlers, the manufacturer doesn't allow the use of vibratory hammers on there. Some telescopic boom crane manufacturers don't allow, unless there's an additional vibration dampener used. So it's a question worth asking. Quickly, there's different types of impact hammers. So this is a vibratory hammer. Now we're briefly talking about impact hammers. No, I got fancy with this one, sorry. So a drop hammer is literally taking a weight, lifting it up, and boom, dropping it on a pile. You can do it by compressed air that lifts the piston up and down. You can, a more common one now is a diesel operated hammer. So literally you have a very simplistic diesel engine. So it has a piston. You inject air and fuel into the cylinder. You lift the piston up. It falls. It compresses the air fuel mixture. And because of the heat of the compression, it ignites, just like a diesel engine in your truck or car or whatever you got. Then there's hydraulic hammers. So they do the same thing as diesels, only instead of using diesel fuel and the compression, they're operated by hydraulic pressure. So those are the most common of all the impact hammers. The last pile driver that you'll see is the dedicated pile driver that we talked about earlier. So there's, again, many different variations of the same thing. But this operator and this machine, they have their own certification. So not crane certification, but dedicated pile driver certification. Dedicated pile drivers have their own set of standards in subpart CC. There's not a lot, but there's some in there. So OSHA is clearly understanding that these pieces of equipment exist. They were unable to get them excluded from being defined as a crane, but they do have some lifting capability, so it's probably a good idea. here's a unit, this is a dedicated pile driver, and they're sorting out the piling that they're ultimately going to drive. So this is well within the manufacturer's limitations. This machine, most of them have a pretty brief load chart. So it will tell you the angle of inclination that the mass can be at. It will probably tell you that in order to do that, you have to put the mass onto the ground for greater stability. It may limit how much weight that you can use and what kind of radius, and it may forbid you from walking. Depends on the manufacturer. Now there's some different products here, and I can't tell you for sure. This is going to be a decision tree that you guys are going to have to go through. So this is an excavator, but they have an attachment. This is a vibratory hammer that has a grab on it. It can grab a piece of sheet pile and they're connected and then physically vibrate it into the ground. Is this a dedicated pile driver? You can argue that, yes or no, but at a minimum, you should ask, is the person sitting in the seat of this equipment, is he or she trained, educated and trained to not only run the excavator, but then to safely operate the excavator with this attachment? Show me that you've trained this individual on how to do it. How do you document that? This is another attachment mounted to an excavator. Okay, this is a hydraulic impact hammer with a very, very, very short section of leads. I have a different picture of this here momentarily. So employers are expected to consider any existing consensus standard. Okay, that's what we talked about, the ANSI standards. So even though they're not legally required, consensus standards represent what experts consider a safe operation. So in my opinion, you should comply with voluntary standards, much like you should comply with OSHA standards, in our case here in the States. So we talked a little bit about that. So in the ANSI standard for pile driving and extraction, it tells you that the contractor should develop a written site-specific safety plan. So in that plan, it might incorporate how to use this type of hammer. I don't know. We talked about the call before you dig, so I'm not going to dwell on it. But it talks about, you may see a mobile crane, typically with what I'm going to call a power unit mounted to the rear of the machine. Why do you do that? Well, you do it primarily for convenience. So this is a hydraulic power unit, much like the one that was on the ground. I showed you with the vibratory hammer. You can't see the hammer in the leads here, but the operator has control of this, and he or she can start or stop the hammer. But this is weight that goes beyond the crane's counterweight. So does this manufacturer allow for you to add additional counterweight and still not affect the crane's, what crane manufacturers call rearward stability? Maybe, maybe not. Most manufacturers that deal with the deep foundation industry have made concessions to doing that. However, the mounting, excuse me, should be designed by a registered professional engineer that's familiar with the industry. The attachment points here to the front of the crane. Who designed them? Probably the crane manufacturer didn't, but an engineer should have designed it to make sure not only do you not impact the safe operation of the crane, but it's structurally sound to take the forces that are going to be generated by driving piling. Sometimes, so a question was asked earlier about getting close to the work, so to speak. And while we're excavating, well, sometimes you got to get close to when you position the freely suspended leads over the next location. So people have to get close by. Okay, to do this with a tag line, it's not impossible, but it's very difficult to fine tune getting it exactly on the spot. So people have to be very cautious of that. These people need to be trained. The conversation that's had either verbally or by hand signals, or maybe even a head nod between the people down here and the crane operator, it has to be very explicit. So oftentimes you can't use the quote unquote proper crane signals that are listed in ANSI and also in OSHA requirement. What a head nod may be a very accurate signal, but everyone on the site needs to know what that head nod means. Otherwise, you're going to have confusion and probably injure or maybe even kill somebody. So the ANSI standard tells you to set up an exclusion zone to keep people away from the pile driving hammer. Okay, this is obviously a staged photograph showing how great all the employees are. but you need to keep all these people away from the actual pile driving operation. More than often than not, people have no idea what's going on, but they're curious and they need to stay away. Most people who drive piles keep people away. Just the noise itself is a detriment to being there, but there's people who are very inquisitive. And flip-flop back to drilling a shaft, that draws people from out of the woodwork because we're drilling a hole and everyone and their brother got to see what they're doing. So controlled access zones, keep people away from what you're doing, please. So these are segments from Corps of Engineers. They have a specific section about pile driving. So I'm telling you this because there's reference information that you can talk about. This information is out there. You may come up to a contractor that's never ever worked for the Corps, so they may not be familiar with this, but at least it's some reference material that you can use to educate yourself, if nothing else. So I showed you this picture earlier. So there's a requirement that says equipment shall be outfitted with a positive and negative restraint to prevent accidental hammer disengagement. Well, that's crazy. You would think we would already have that. So uncontrolled rising out of the leads, as well as preventing contact with head blocks or sheaves, or shivs, I'm sorry. So nice on a piece of paper, what does that mean? Okay, so here's that hammer. It's inside a set of miniature leads here. Big hammer. You can see how big it is. This is a 6 foot tall gentleman. Okay, so they did this because there's low overhead clearances. They were working underneath, I can't remember, a power line, I believe. So pretty common thing to do. However, here is another picture. When the operator is sitting in the seat to try to raise the hammer and leads off of the pile that they just drove, he angled the leads back. This big giant yellow hammer here slid out of the leads and landed directly on top of the operator's cap. So there was no stop in here to prevent the hammer from coming out of the leads. That's why this says that in the EM 385 1-1. It also says it in the ANSI standard. So unfortunately, in this case, safety is a reactive thing. We had a bad fatality accident. We had to make sure that it never happens again, so we incorporated it into safety standards. Weekly documentation of the pile driving leads, okay? So it's not just the cranes, not just the booms, not just the counterweights, not just the connecting points. The leads themselves, they can suffer from a lot of wear and tear. There's impact, there's stresses, and there's strains. There's all kinds of things that happen when you drive a pile. So they need to be inspected. The Corps says they need to be inspected weekly. I would agree with that at a minimum weekly, but you should do a cursory inspection pre-shift, my opinion. So here's a picture, before and after picture. We have fixed leads. They're physically attached here. These are well over 100 feet in tall. Okay. A couple of days later, same crane, same leads. Boom, we had a lead failure. How did it happen? We don't know exactly what happened because we're all standing here gaping with our mouths open going, how'd that happen? Who screwed up? Who did but blah, blah, blah. All the fingers are being pointing in every direction, but we couldn't figure out why. We had several different cranes come in. We lifted, we cut this piece off. We had 100-foot aerial lifts up here. We cut all this out as much as we could, safely lifted it to the ground. Then we did an inspection. We found that over time, part of the lead section had rusted, had a weld joint. And because a weld oftentimes has pinholes in it, over the years, water got into the pinholes and got into, this is a piece of square tubing. So this contractor is in Ohio, so we have freezing and thawing. So when water freezes, it expanded. So it further, in this case, drove this crack to be even bigger. This is a weak point. We found out under our investigation, this was the causation of that failure of the leads, okay? Could inspection have prevented that? Of course it could, but it's pretty hard to inspect something 100 feet in the air. So how do you do that? Used to be we would climb the leads using fall protection, but now what do we use? We use drones because that's a better way to do it. It's faster and you can see without even exposing yourself to a fall hazard. Okay, so if you're adapting pile driving equipment, again, this is Corps of Engineers speak here. You need, if you're adapting pile driving equipment to a different unit, like a forklift to drive piling, then you have to train the operator on how to do that. So this is a industrial forklift. Operator has to have forklift certification, we know that. But now this operator also has to be educated and trained on how to use this attachment. Okay, if you attach, in this case, a hydraulic impact hammer to a forklift, this connection point has to be designed by a professional engineer to make sure nothing can happen. Inspection, of course, you got to inspect the forklift, the mast, the forks, the connection, the hammer itself. I like to say when you drive a pile using an impact hammer or a vibratory hammer for that matter, the whole unit goes into self-destruct mode. It's beating against itself and things wear out. So you got to constantly inspect them. And if you see a problem, you got to repair or replace it. Dedicated pile drivers suffer from overloads just like cranes. Okay, they're very sensitive. So I believe in this particular incident, they were tramming or walking this dedicated pile driver forward. The pile was freely suspended and it drifted away from the mast, and that caused an overload, which then in turn tipped the machine over. But in order to understand that, you have to not only know how much your machine weighs, how much the pile weighs, but this one's outfitted with an auxiliary auger to pre-drill for the driving of the pile. So did they take into consideration the weight of that when they were using this to drive this weight of pile? Lots of things to factor into the trim. Yesterday we talked about safe working platforms. It could be that the poor working platform contributed to this partial overturn. Again, this is not a dedicated pile driver, but it's interesting that the crane operator and the foreman here are having the conversation while the crane is in almost tip over mode. What should we do now, boss? Not sure. But it's very easy to extend beyond the limitations of a mobile crane or a dedicated pile driver. So this is an interesting. We're pleased to know that they were successful in safely getting this back down to the ground. No one was hurt, no equipment was damaged, but nonetheless, a pretty scary moment. So they constantly have to be aware of the rated safe working radiuses and know the weight of the piling leads in this case, the piling hammer, and the weight of the pile. And this is slightly downhill and not level. So if they had this load suspended, that load is going to drift to the low side and maybe away from the crane. It's conceivable that just the weight of the suspended load drifted out further than the assigned radius and started this machine to overturn. They probably weren't doing anything except the operator probably quickly set it down. Don't know for a fact, I'm speculating. In New York State, they have a large bridge called the Tappan Zee Bridge. You may have seen this on the news. This happened a couple of years ago. Big, giant lattice boom crawler crane. Has weights that are on the back that actually extend out as you boom this machine down. It's a pretty cool lattice boom crawler crane. Not necessarily the crane of choice to run a vibratory hammer, but they had it in place. They had it setting on the new bridge. They were driving these steel pike piles. This is the hydraulic control unit for the vibratory hammer. The vibratory hammer, I think, is in the water. I'm not sure. It might be over here somewhere. But you see all this boom. I want to say it was somewhere in the neighborhood of 300 feet of lattice boom is now laying all over the place. So how could you destroy a brand spanking new lattice boom crawler crane simply by driving a pile? Well, if you're not careful and you're not paying attention to what's going on, driving forces or affects the crane, but extracting when you're using a vibratory hammer, you can drive the pile into the soil, but you also have the capability of pulling the pile back out. Why would you do that? Well, maybe it's going out of tolerance. Maybe it's driving cockeyed or crooked. Maybe you don't like the position. So you can pull it out and do it and have a do-over essentially. It's a pretty neat thing to be able to do. However, when you're extracting, if you're not making sure that the grip, this isn't from this accident, this is a different picture. But if you're not making sure that the grip, these are the teeth that actually grip this, in this case, this section of pike pile here. So the grip, again, this is not from the incident, but the grip failed. In this case, this jaw failed. So if you can imagine you taking something that's vibrating furiously over and over and over and over and over again, you get metal fatigue. So if you're not inspecting, there's bolts that hold this to this movable jaw. If you're not inspecting this jaw, if you're not inspecting the entire hammer, the hydraulic hoses and all that, and you have a failure, and that hammer, you're pulling on it with the crane and it suddenly lets go of the pile, what's going to happen? Well, a sudden release of the load is going to cause the load to shoot up, and now this crane boom here is going to go in this direction because it's slack. So you can't see these pennant lines up here. They go way up to the top. But these pennant lines got slack. This boom was almost vertical. And then it went back the other way. And when it fell the other way, like here, it broke all the pennant lines, and then we had a massive structural failure. So the simple extracting of a pile can cause a tremendous amount of damage if inspection is not taking place, if the operator in the crane is not familiar and understands what can happen when you not only drive, but extract a pile in this case. So all the talk about training and education is paramount to keeping things safe and when you're in the pile driving world. You could have a job site that's got lots of activities going on at the same time. So this has 3 pile driving rigs going on in the same job site, okay? Can one impact the other in a negative fashion? Yes. If we have a crane overturn or a pile falls out from underneath the hammer, lots of bad things can happen. So we have to have a plan. We talked about planning earlier. Got to have a plan to make things go right. When you cut off a pile, these are driven to grade. These are driven to the proper depth, but we have excess amount. So if someone comes in here and cuts them off to the proper grade, it's very common. Could be pipe pile like this, could be wood piles, could be H piles, could be concrete piles, doesn't matter. That's a very common thing to have to cut them off to grade for the foundation cap that goes on top of it. But in this particular incident, this company had a plan on how to do this. They had set up an exclusion zone, they had a technique, but unfortunately the individual doing the actual cutting did not follow the procedure to some degree, and they also allowed an inspector who was just doing his job into the exclusion zone. The inspector had his back to the operation, and when the gentleman actually cut the pile off, it fell. That was their plan, to have it fall, but there wasn't supposed to be anyone in the exclusion zone. And you can imagine the pipe hit this gentleman and killed him almost instantaneously. So we're not even driving a pile, we're cutting them off, but the hazards still never, ever go away. We talked about ground conditions yesterday. Again, this is not the proper way to find a utility vault by tramming your crane across it. So we have an overturn. This is ugly, lots of damage. We talked about it yesterday. I'm not gonna. So A1019, the ANSI standard has the same verbiage as the OSHA standard does. A lot of people like to talk about crane mats. Crane mats are wonderful devices, provided that you actually keep the crane on the mat. This is a job site in Louisiana. If you remember, they had a little storm called Hurricane Katrina. This is part of the levee reconstruction. This is a large crane. This is a 300-ton crawler crane. It had 300 foot of lattice boom. They didn't have a spotter. The crane was tramming backwards. It walked off the mat and completely flipped this crane over. Destroyed not only the crane, but somewhere in the neighborhood of 150 feet of piling leads and the hammer that was in there. So bad, nobody was hurt, or somebody was hurt, but not killed. Bad accident, destroyed a multi-million-dollar pieces of equipment. Not having a spotter, okay, we walked off the mat, but this contractor walked backwards into an open excavation. And at the edge of the excavation, the soil collapsed and took the machine down inside of it. Again, should we have had a spotter? Absolutely, to watch where the crane operator can't see. This happens, unfortunately, a lot when you're driving a pile. It's hard to see, but this pile, this is a reinforced concrete pile, is driving crooked or out of alignment. So as you keep driving, you can actually, this pile actually goes up inside. This is called the helmet. So the top of this pile is actually somewhere about here. So as you keep driving with this diesel impact hammer, you can see it's wedging itself into the leads and against the pile. If you're not careful, you can cause side loading of your crane boom. If you try to pull this off, you can cause side loading of your crane boom. How do I know? Because this accident just took place in Houston approximately, I think, last month. This contractor was driving piles. Their pile went off tolerance. It jammed in there. The crane was situated so it was working perpendicular to the leads. I'm sorry, parallel to the leads, not perpendicular. This is a different crane. They tried to pull this off the pile. They side loaded the boom and it failed. It buckled somewhere just above the boom stops here. And unfortunately, it landed, the boom tip landed on a passerby on the interstate and killed the 2 individuals in this pickup truck. So driving piles is actually kind of boring. It's monotonous until something goes wrong, and things can go violently wrong. So paying attention, working within the parameters of what the equipment manufacturer says you can and can do, training, education, certification, all keys to the success. Fall hazards, of course, okay? Old schoolers did this. We don't do that anymore. People actually would climb to the top of a sheet pile to engage the next sheet. We don't do that anymore. We work out of aerial man lifts or platforms, whatever you want to call it, like Dan was talking about yesterday. So actually, people moaned and groaned about doing that, but once they learned how to use it, they actually did. Not only were they more safer, but they were more productive. They were actually faster. Interesting. So to finish, this is some of the stuff you guys should be looking at if you go up into a job that's pile driving. I'm not going to tell you how to do your job, but these are things so you'll have access to this slide. This is also a project takes place in levee repair right after Katrina. Some of these cranes are driving piles. Some of these cranes are service cranes holding the pile as it's being driven. At the peak of this project, there were 128 lattice booms sticking up in the air. A really cool project. I was proud to be a part of it. Mr. Craig, that ends my presentation. So we're open for questions if there are.
Holy moly, and here I thought the place where I saw most lattice and hydraulic booms from cranes was Las Vegas at certain times, but this picture has anything I've seen in Vegas beat. Wow, that's a cool picture. You know, I was thinking to myself, if I were to have ever been asked the question by somebody, what doesn't Rick Marshall know? You know, I was kind of racking my brain and thinking, well, maybe, you know, quizzing him on his home state. So during break, some of you may have been privy to it. Some of you may not have been privy to it. I was trying to establish an answer to that question, what Rick Marshall does not know. So we quizzed him a little bit about his home state of Ohio, and we asked him, what's the state bird? And Rick, of course, without hesitation, well, I believe it's the cardinal. So, of course, we had to go to our dictionary of choice these days, which is called Google, and look at what Google says. Google agrees. It is the cardinal, Rick. What don't you know?
I just use Google a lot, so there you go.
Thank you so much. That was tremendous. Yesterday was tremendous, and hopefully you can stay on until we wrap by noon to listen to the Oregon OSHA side of things. So what we have coming in, let's go a good break, a 15-minute break. So we'll reconvene at 5 after 11, and I think we'll still be okay. And when we reconvene at 5 after 11 Pacific time, so 5 after the hour, we will be joined by Matt Kaiser of Oregon OSHA, and he will give us the most current update, as it seems to change daily, on our infectious disease prevention rule, otherwise known as our COVID rule. And then we will be joined by Mr. Brian Snap, who is our statewide safety enforcement program manager, and he will provide us a case study from a fatality from a few years back, in addition to a brand spanking new directive that will be coming from Oregon OSHA in the very near future. And then as we wrap closer to noon, I have a few other tidbits that I will share before we formally close the webinar. So let's reconvene at 5 after the hour, please. 5 after the hour.
Thanks, Rick. Thanks, Craig.
Thank you, sir.
Thanks. Let me stop the recording here. All righty, welcome back. everybody. And this is the final hour of our webinar this morning, and we are lucky to have joining us Mr. Matt Kaiser. Matt Kaiser is one of our highly esteemed technical specialists here within Oregon OSHA, and his name has been attached to our infectious disease prevention rule. And I will allow Matt to provide some insight in this rule of ours that started temporarily and then became quote unquote permanent, and where we stand today. So Mr. Matt Kaiser, everybody.
Thank you, Craig. Appreciate it. It's always a nice opportunity to be able to share a little bit more where we're at with COVID-19, at least in regards to where Oregon is at. Because as you had mentioned earlier, things do appear to change and change quite often. And so it really, COVID-19 really is the public policy gift that keeps giving. And by giving, I mean giving us plenty to keep us on our toes. So really glad to have the opportunity to share a little bit about where we're at with a couple different things. And so what I wanted to really highlight were three things, at least in the 10 minutes or so I have right now. The first is vaccine verification. The next is federal OSHA's emergency temporary standard that was released not too long ago, and what that means for Oregon's workplaces. And then finally, Governor Kate Brown's 70% vaccination goal and what that's expected to mean in regards to Oregon's workplaces for things such as facial coverings and distancing. So go ahead and kick things off with a little overview of the vaccine verification aspect. So many of us probably by this point are quite familiar with the mid-May CDC guidance update that recommended that fully vaccinated individuals do not need to wear facial coverings or practice physical distancing. And so in Oregon, we responded to that by collaborating with the Oregon Health Authority, which is, of course, our public health entity here in the state. And Oregon OSHA issued a enforcement policy guidance that essentially provides employers in Oregon with the option to go ahead and use this vaccine verification option for Oregon workplaces. And so what that really means is Oregon employers can either choose to continue with facial covering and social distancing requirements as they've been in place largely since at least November of 2020 when Oregon OSHA adopted temporary rules for COVID-19, or they can choose to use this vaccine verification, which would mean if they verify the vaccination status of the involved individuals that they don't need to use facial coverings or practice physical distancing. And so I really think that Oregon struck a really unique balance by providing employers with the choice to, again, continue with the requirements as they've been in place for several months, or to, depending on their particular workplace and the operations that they perform there, to go ahead and implement the requirements for this vaccine verification in line with the Oregon Health Authority interim guidance for fully vaccinated individuals. Now, the second thing I think is important to touch on here is that federal OSHA recently released its emergency temporary standard related to COVID-19, and their temporary standard, their ETS, emergency temporary standard again, is specific to healthcare. And so many of us in Oregon and Washington, of course, know that our two states are what are called state plan states, which means that this federal ETS actually doesn't apply to our state. However, each state is required to implement measures that are at least as perfective or at least as effective as the federal ETS. Now, in Oregon, I know that we've already launched into our response to that federal ETS. So last week, I spent a lot of time developing a side-by-side analysis of this healthcare-only ETS that federal OSHA came up with in comparison to our Oregon OSHA rule, which includes requirements not only for exceptional risk workplaces, which are direct patient care, emergency responders, but also have requirements for all workplaces. And so we also have kickstarted discussions with different stakeholder groups and have really begun some of the meetings required to just ensure that we are doing, again, what needs to be done to make sure that the federal ETS and what Oregon OSHA is currently doing is meeting that just as effective threshold. Now, with that said, it certainly helps that in the time that federal OSHA took to develop a healthcare-only COVID-19 rule, at least in Oregon, we were able to develop, promulgate, and adopt 5 rules related to COVID-19, some of which were temporary in nature and some of which are more final or normal in nature, quote unquote, permanent. And I'll just go ahead and say the word permanent, at least in this point, is reflective of the Secretary of State's language related to rules. Oregon OSHA does intend to repeal its COVID-19 standard that is in place now once it is no longer necessary to address the pandemic in Oregon. And so, and for those who are interested, Oregon does have rules related to COVID-19 protections, not only for exceptional risk workplaces and all workplaces, but we do have COVID-19 employer provided housing rule, which is does have an impact on things such as ag labor housing and things of that nature. And then finally, before we open things up to questions, I think it's relevant to touch on Kate Brown's commitment that once 70% of 16 or older individuals in the state of Oregon have received at least one shot for their COVID-19 vaccine, that will be a threshold once met, that facial covering requirements and physical distancing requirements statewide will likely dissipate and be reduced to a point where they're largely not required anymore. And so what that has created for us is a need for Oregon OSHA to collaborate again with the Oregon Health Authority and the governor's office. And we're having meetings throughout this week and even later today with those various stakeholder groups to really make sure we have a clear path forward for what we're going to do once that 70% threshold has been met. And if there are going to be requirements for certain settings, such as public transportation, for example, or certain aspects of healthcare that would continue to have some aspect of source control or facial covering requirements for different individuals that are entering those places and how vaccination might impact those things. So plenty of work still to be done in that nature, but I thought it was relevant to touch on that here, just in case there was anyone who wanted to know if we were aware or if what we were working on in that regard. And for those who are curious, it looks like we have Oregon OSHA's infectious disease rulemaking page pulled up, and you can see in that orange bar, for those who are interested, it looks like Oregon's about 60,000 vaccination jabs away from meeting that 70% threshold. And I know in conversations with the Oregon Health Authority earlier in the month, they were hoping to have reached that threshold by the 21st of June, but it looks like it's going to be sometime between, the 21st and probably the end of the month here. It certainly sooner would be greater and would be welcomed by all involved, but nonetheless, we still do have 60,000 individuals that need to go through that vaccination before we reach that 70% threshold. And then finally, I'll go ahead and drop my contact information into the box, and this is really just a bonus for anyone. I'm more than happy to be a resource to anyone who wants to chat about the COVID-19 rule or chat about anything occupational health and safety related, or see if there's anything I, or by extension, my colleagues, other technical experts that we have at Oregon OSHA can do to assist you, make sure you have the resources, the information, the letters of interp that are going to be relevant to you and your work, the individuals that you're working with, different employers, and by extension, the great workers that our two sister states get to serve. So I wanted to go ahead and stop there and see if there's any questions. I wanted to make myself available after today in case anyone wants to follow up with me. But again, just touching on that vaccine verification element, federal OSHA's emergency temporary standard, and then finally, what does this 70% threshold really mean, and where are we going from there in regards to Oregon OSHA's COVID-19 rule and some of the components which do include facial covering requirements and physical distancing. So I'll go ahead and pause there. If there are any questions, happy to address them as best I can here. Of course, Brian Snap has a lot of experience addressing a lot of the enforcement related questions as well related to COVID-19, but I'll go ahead and pause there. See if there's anything I can do to further elaborate.
Yep. And Matt, I'm going to just limit it to 2 questions because I don't want to encroach in Brian's time too much, but we'll certainly provide your contact info when I send out some follow-up correspondence. First of all, is it 16 plus or 18 plus, 65% or 70%?
In Oregon, it's 16 and older.
Okay. And just a final question here. Are you concerned that we are not meeting the Fed's requirement of as protective or more protective for trainings and testings that are currently not required under our memo since March of 2020. For instance, blood lead testing.
So as I had mentioned last week, what I was really focused on doing once federal OSHA published their emergency temporary standard, each state is required to respond to that with a side-by-side analysis. And so that's what I was able to do, is bring in the different components of our existing rule. And I mean, I'm happy to say that federal OSHA appeared to borrow quite a lot of language from what was already in place in our rule, which was great. And really see if there were gaps. And I can, you know, thankfully say, knock on wood, that we don't envision any major difficulties in regards to meeting that just as effective as threshold in regards to what is currently in place with Oregon OSHA's rule, which of course applies to all workplaces, is important. So I think that definitely gives us a little bit more of an edge towards that understanding that our rule, of course, has been in place since November in the form of a temporary rule, and then has been in the form of a permanent rule, or quote unquote normal rule, since the beginning of May. And so that certainly gives us additional, you know, I would say validity to be able to say we were doing quite a lot in response to COVID-19 to protect workers, not only in healthcare, but also beyond healthcare in regards to exposure risk assessment, employee training, and then infection control planning, things of that nature. And so I was really quite pleased where we ended up after that analysis, and we're really excited to see, again, what's going to happen after we get to that 70% vaccination threshold statewide. So
that was the second part of Jeff's question. There's 65 or 70%, and we're already beyond 65. I think we're at 68%. And like you just said, I think 70% is our goal.
Mm-hmm. And the inquirer might be asking a little bit. So in Oregon, I know there is a statewide goal of vaccination rate of 70% of individuals 16 and older. And so that's a statewide goal. And then per county, if a county can get to 65% of its same eligible population vaccinated, or at least one shot, that then they move to the lowest sector guidance metrics for that county. So instead of operating at extreme or high risk, which limits, say, capacities in restaurants or the ability to do larger gatherings and things of that nature, it would essentially move that individual county to the lowest risk requirements of the existing sector guidance that's put out by the Oregon Health Authority. So that's not a component of Oregon OSHA's rule, but that is nonetheless something that we get a lot of calls about in our technical section. So 65% for county or 70% statewide. It really depends what aspect you're really trying to talk about or go after.
Great. Thanks for that clarification.
Yes, thank you, Matt, owner of A Lovely Vizsla, technical specialist, and his contact information is right there on our infectious disease prevention rule page. Matt Kaiser, thank you so much.
Thank you for having me. I'm going to go ahead and drop my info into the box. Let's see, here we go.
And while you're doing that, Mr. Brian Snap, I will make you presenter. And my goodness, everyone, not only does Mr. Brian Snap climb mountains and climb rocks, he climbs through all kinds of statewide safety enforcement matters for us. And for a handful of years now, Brian Snap has been on board with Oregon OSHA, not only as statewide safety enforcement program manager, but also starting as a technical specialist himself. So Mr. Brian Snap, everybody.
Well, hello, everybody. Let's start off here, Craig. What are you seeing? Are you seeing me, or are you seeing a screen of mine?
Let's see. What I see is
both.
Your. I see a page out of the firm.
Okay. I think I figured out how to make it so everyone can just see me for a second while I introduce myself and what we have going on, and then I'll switch over. So Good morning, everybody. Thank you for the invitation to be here. I've got two separate topics that I'm going to share with you guys today. The first one is the program directive that we are developing here at Oregon OSHA, revolving around underground excavations and utilities, such as electrical, natural gas, water, telecommunications, all of that sort of stuff. And then the second thing is going to be a short synopsis of an accident that, or a fatality actually, that we investigated back in the summer of 2018. So I'm going to go ahead and start off with talking about the program directive. So here I'm going to go ahead and share my screen. I'm going to pull up, I'm going to get out of the firm here, get into our actual rule page, which is for some reason hanging up.
I should have mentioned, not only do you climb rocks and mountains and climb through all kinds of matters, you also climb through a lot of desktop icons and and various things in your toolbar. You're a busy man.
This is crazy because we had practiced this during the break, and now I can't get it to switch over to the page that I wanted to show on our website.
I wonder if you even tried, have you tried minimizing that maybe to wake it up? Because I bet it is stuck.
Let's see here. Well, I'm going to go ahead and talk then without taking you guys to our website. And maybe we'll have more success there. So I'm trying to close out a few items here. Okay, here we go. It's popping up, so I'm going to go ahead and share.
Yep,
so can you see the website now?
Sure can, sir. Yep, the website just did appear.
All right, so for everyone who's not really familiar with Oregon OSHA and our website, our homepage brings you here to this beautiful picture of our coast. What I'm going to do is I'm going to take you to where our program directives live. So on our banner up at the top, there's a section for rules. When you click on rules, that will open up a section that drops you down into our rules that apply to employers working in the state of Oregon. You can see that we have different divisions. Division 3 is the one that's most likely going to be of interest for most of the individuals on this presentation today, because that's our Division 3 construction regulations. Off to the side here, you'll see that we have other information, and coming down below, we have a section for rule guidance, and this is where you'll find our program directives. So I'm going to pull up our program directive page here really quick, because there's great information here for you as employers. So the program directive that I'm going to talk about here in just a second is one that we are developing about underground utilities and the avoidance of them and what rules apply, that sort of stuff. But since we've spent a day and a half talking about all sorts of things like cranes and dedicated pile drivers and that sort of stuff, if you were to come in here into our search bar and just type in the word crane, you are going to see that we have program directives that pop up related to cranes. And the big one that I wanted to point out here before I move on is our program directive 296. 296 brings up the program directive that tells us here at Oregon OSHA how we want to conduct our inspections and how we want to consider different violative conditions and how we're going to cite them. So it's an internal guidance document for ourselves. It's our policy, not the rule, but the policy on what we're going to do on a construction site when we're out there doing an inspection. So this is a great document that's on our website for you as an employer. So you have a rough idea what we're going to do. So you can pull up this document. It is 213 pages long, but it has all sorts of great information so that you're not caught off guard or you're not surprised by what an Oregon OSHA inspector is going to look for, what they're going to ask about, and what they could possibly cite on your location for cranes and derricks and dedicated pile drivers, that sort of stuff as it relates to construction activities. Now, we do not have the program directive in here yet for the underground utilities because it's still under creation. So what I'm going to do is I'm going to take us back to our rules page, and I'm going to slide down to our construction regulations, because I'm going to show you the rules that we're talking about that are going to lead to this new program directive. And I personally know that the excavation rules live in subdivision P here in Oregon. So here are all of the rules in Oregon that apply to excavations. So a couple things I'm going to point out here. Probably the most important one for everyone on this call is the definitions. It's really important that you guys know what definitions we are looking at. So in Oregon here, as well as federally, for OSHA, an excavation means any man-made cut, cavity, trench, or depression in the earth surface formed by earth removal. So most of what you guys are doing very easily fits within the excavation regulations, because you are making a cut, a cavity, a trench, or depression in the surface of the earth by removing earth. But one of the reasons why we are creating a program directive is because there are activities that put underground utilities in danger, and by extension, put employees in danger through electrocution, shock, exposure to natural gas, fires, explosions, that sort of stuff. Rick had mentioned drowning, where excavations fill very quickly because large pipes are damaged, water pipes. So not all activities that could damage underground utilities are created by an excavation. So think of something very simple. You go out into the middle of a field and you take a concrete form stake, a round stake, and you just pound it into the ground. And you pound it into the ground straight into an electrical conduit, and you get electrocuted. Was that an excavation activity? To us here at Oregon OSHA, it was not, because the pounding or the driving of a concrete stake into the earth, it made a depression. There was a depression, but it was not caused by the removal of earth. So if we take this to a larger example, an example where many of you here on this presentation would probably be interested in, would be the insertion of an H-beam to start creating soldier piles in that same field. So instead of walking out in the field and inserting a concrete stake that is 3 feet long, you insert a H-pile by mechanically vibrating it or driving it into the ground without ever removing earth to do it. You're just inserting it into the ground. Would that be covered by Oregon OSHA's excavation rules? Unless you guys took a shovel out there and scooped out a scoop of dirt first, or took a excavator and took a bucket of dirt out of the ground first, or a dozer of some sort and scraped away some dirt first and then drove that pile, we would not say it was covered by the excavation rules. So if it's not created by the excavation rules, what other rules apply? And that is going to be the magic of this program directive. So 99% of what we do inspection-wise at Oregon OSHA is related to these excavation requirements. But we do have situations where the excavation requirements don't apply. And if they don't apply, we have to find other rules to get there. So the rules that do apply to excavations when earth removal has occurred prior to the activity or during the activity are going to be our rules that all fit on a single page. So here in Oregon, all of the rules related to underground utility protection, and by extension, the protection of employees, all fits on one page. So it's 1926-651 specific excavation requirements, section B, subsection 1, 3, and 4, in addition to a very limited set of Oregon OSHA state-initiated requirements. So where we get a lot of confusion here in Oregon is the confusion between Oregon OSHA's health and safety rules for excavations and the protection of underground utility installations, and the Oregon Public Utility Commission's regulations for protecting those very same underground installations. So here in Oregon, we have a memorandum of understanding between Oregon OSHA and the Oregon Public Utility Commission that if there is damage to underground utilities that the public created or puts the public in danger, the OPUC will handle that. But if there is damage or could be damage where employers put employees at risk, then Oregon OSHA has jurisdiction and we will investigate it. So our rules are really basic. Our rules are also a little bit outdated. So when we look at the underground utility installation rules, the very first one, and it will be covered in the program directive, says all excavators have to estimate the location of underground utilities prior to opening the excavation. So this isn't knowing the exact location, it's estimating where the utilities are underground. So if you're excavating on the side of a road, is it reasonable that there could be underground utilities such as natural gas, water, electrical, that sort of stuff? If the answer is yes, you need to roughly estimate where they are. Where would they reasonably be? And so here in Oregon, the Oregon Public or the OPUC requires you to call them, so 811, and wait the appropriate amount of time for the locators to come out and put the paint on the ground to estimate the locations. For Oregon OSHA, that is the best method possible. That's what we want you guys to do. But Oregon OSHA will actually accept a couple other ways of estimating that the Oregon Public Utility Commission will not. So we'll accept an employer who will go out and hire a private locating contractor and call that in. Or maybe they hire staff, train their staff, equip their staff, ensure that their staff are qualified and competent to do their own utility estimating. That's really rare, but if an employer can prove it, we would say that it has met the requirements of B1 for estimating the location. Now that is a significant difference between what Oregon OSHA can hold an employer to and what the Oregon Public Utility Commission can. So that's going to be all outlined in the program directive. B3 here is really important. So after you estimate, after you've estimated the location of underground utilities, you must determine the exact location by safe and acceptable means. So as you start excavating and you start approaching those estimated locations where the paint is on the ground, you need to transition to safe and acceptable means to determine the specific location so that you can avoid those underground utilities. And this is where we see this quite a bit, where there's contact with underground utilities because they didn't transition quick enough. They're going to take just one more scoop with that excavator bucket, and they thought they had a little more wiggle room, but they didn't. They strike the utility, and then there's an exposure to employees. One of the things that's unique here in Oregon is we used to have B2, and in Oregon, we did not adopt B2. We instead, we adopted an Oregon initiated rule, and that Oregon initiated rule's up top here. And at one point in time, that Oregon initiated rule pointed to the rules put in place by the Oregon Public Utility Commission. And so for a long time, we were able to enforce all of the Oregon Public Utility Commission rules as if they were our own. Unfortunately, back in 2011, those rules, which are referenced right in here, changed. The Oregon Public Utility Commission went out and changed their rules. So now our rule that points at their rule points at rules that are gibberish, essentially. They don't mean anything for underground installation safety. So that is part of what this program directive is going to do, is talk about the relationship of our rules, their rules, and what we are going to cite when we come across situations where there is potential damage or damage to underground utilities. So with that, before I move on to our quick case synopsis, I just wanted to see if there were any questions that might have come in, Craig. So that was a really brief overview of the coming program directive.
And thank you, Brian. No questions that I see. And unless I missed it, did you offer a timeline or any idea, Brian, of when this might be released, posted on our website and raring to go?
I was working feverishly to try to have it 100% completed and ready to be posted on our website before this symposium. I'm expecting it's probably going to be another 30 days just because we have to do all of our internal reviews and audits of it before it's finalized. So
gotcha.
Definitely this summer.
Very good. And you did a great job in directing everybody to where we plant and where we house our program directives. So while you're transitioning there to your slideshow, again, for everybody on the call, we have our A to Z topic index, also a search function up there. And then as Brian showed us all, just clicking rules, and there's a link to the program directives also right there on the rules page.
All right, I'm going to go ahead and transition into our fatality investigation here really quickly. Let's see here. Should switch away from me.
Yep, we see the picture. Nice cliffside.
Oh
Looks
gosh,
like a nice...
I just clicked back out of it. Oh, I gotta be patient.
No problem.
So
What we see on our end, Brian, is
let's
the
see.
picture of the cliffside there and the cutout.
Okay. Did it just switch to the next picture where you see a red arrow?
I do not see a red arrow.
Oh, come
See the
on.
piece of equipment up there on the ledge. See that it's a nice sunny blue sky day. Looks like there's some recent sloughing of the rock and the sand and the dirt down at the bottom of the hill, but it's just that one picture so far.
Okay, well,
You must have really been
I've got the
working your
PowerPoint.
hard this morning. It's exhausted.
Okay, so
There we go.
there we go. Okay, you
Yep.
see the red arrow now?
There we
Okay,
go.
all right. So what we have here, this is back to the very first picture. We have a road building project that's going on here at the site of a quarry back in 2018. What's interesting about this is that there are multiple employers involved. So we have a property owner who owns the quarry. They own the forest around the area. They have some direction and control over what occurs on their land. They wanted this road put into the top of this knoll, which would then eventually become part of the quarry. So they hired some contractors to come out and do that. So we have a general contractor who was hired to build the road. And that person has a few employees. There was a subcontractor that was hired by the general contractor to pioneer the road up there. So the subcontractor's job was to drill and blast the road going up. And then we have another employer on site who actually holds the explosive license to purchase the explosives, but that's all that contractor was really there for, was to have the license. He was not a explosives specialist. So he just had the license so he could open the explosive locker, and then other people would take the explosives and fill the holes and do the blasting. So we end up with 4 different essential employers on site here. The primary one is a subcontractor who's the employer and 2 employees. Their job is to go up there and pioneer this road in. So this red picture, or this red arrow here, is showing the site where the fatality occurred. Like you can see, we've got a drilling rig right at the very end where the road is being developed, right at the edge of the quarry. And so here's a picture looking down from that exact same location. So you can see the forest lands, the roads, the edge of the quarry on the right, and then the steep drop off down into the quarry area below in this picture. This picture is shooting across, and in this picture, the drilling rig is right up towards the top here, just barely out of view. So it's just another presentation of the landscape we're looking at here. Here's coming up the road that's being pioneered to the top of the knoll and the back of the actual drilling rig. So what we have here is an Ingersoll Rand ECM 490 drilling rig. What's unique about this? Well, I guess it's not unique. It's an older machine, so it can put multiple sticks on for drilling into the rock face. At the time of the accident, there was only a single stick. The sticks are 12 feet long, and they have a carbide button tip that with this machine could drill about 1 foot per minute into this rock type that they have here. As you can see, looking at this rock face, The rock is quite fractured. It's in bad shape, and it's not in bad shape as the result of the blasting that has occurred. It was just in bad shape to start with, and then they're blasting on top of it. And then, of course, above it, we have forest soil and trees, stumps, all sorts of stuff. Here's another picture of being right at the drilling machine, looking up into the fractured rock. A lot of open books, a lot of seams, a lot of cracks. And so what the process was here is the employer who was in charge of the drilling and the blasting would move the drilling machine forward. They would go up and they would spray paint where they wanted to drill the blast holes. They would drill it. Another company would come in, fill the holes, and blast it. And then the two companies together would essentially come and clear the road, scale the face, make sure that it was safe, and then they would move the drill rig forward and repeat the process. So some more pictures here. And then in this picture here, you can actually see where the fatality actually occurred, because all of this jumbled rock here came off of the rock face up against the rock drill, crushing the employee right in the middle here as he was attempting to drill way out here in front of him with a single stick on the rock drill. The rock face unexpectedly came down. Now, this rock drill has a single set of controls, and the controls are on the left-hand side of the machine. So the only way that they could do the drilling here was with the employee positioned between the rock face and the machine. Newer machines and other machines of this age have controls on the left side and on the right side, or at the tail at a minimum. So when we began investigating this, one of the first things we asked was, why did the employee have to be here? And the configuration of the controls partially answered that. Another view here. Here's a closer up shot of the rock that actually fatally killed the employee. And some more of the rock face. You can see the spray paint up on the wall here where they were trying to drill the hole. As you can see, where the rock face failed wasn't where they were drilling. It's areas where they had already drilled, had already scaled, and they thought were safe. Here's the other side, no controls on the other side. So another shot here. So essentially, this is a view of what a similar looking machine looked like. I'm pretty sure you guys are familiar with rock drills. And this is what we eventually ended up citing the employer for. We did not cite them out of our construction rules because we did not have an applicable rule related to what they were doing, but we did cite them out of our general industry rule for training and for supervision. So what we found here is the employee who was killed was still in the process of being trained. His training was not complete. Most of his training was on-the-job training provided by the owner of the company, the subcontractor who was hired to pioneer the road up there. He had done several weeks worth of training and then had a need to fly to Hawaii for business purposes. So he left, and he left the employee in charge of himself and asked one of the other subcontractors on the site to supervise this employee in the work that he was doing. In our investigation, we determined that the other person who was doing the supervising, who was the subcontractor doing another job on the site, had no idea how to safely do rock drilling. So essentially what we did is we cited the employer for not fully training the employee and then also not providing adequate supervision of that employee while he was performing his task. So that is a real rough overview of what we have. And let's see here if I can return this back over to Craig.
Well, and I can take care of that for you also, Brian. Just a couple of quick questions, though, while we have you. First of all, was there a jurisdictional issue here at all with MSHA, Brian?
Yes, at first we thought for sure it was MSHA's jurisdiction. So we reached out to them. We tried to coordinate with them. They reviewed it all. They said, nope, it's not us because it is not actually quarry work. They were pioneering a road to get to the top that eventually someday would become a quarry, but they weren't removing that rock for the process of taking it down, grinding it into usable material. It was just being thrown off the side and then was probably going to eventually be turned into usable material. So MSHA declined to investigate it. And Oregon OSHA's jurisdiction is we actually do have the ability to investigate within the mine area of the mining operations, but we defer to MSHA when MSHA is willing to take it. In this case, they were not, so we went ahead and moved forward with it on our own.
Very good, sir. And lastly, did we look into this piece of equipment for the possibility that it could have been retrofitted to have the controls available on both sides of the machine? And if that was an option for the employer and they chose not to spend the money or investment to do so, could we have cited it still general duty or Division 1?
That is essentially what we did. Is I didn't show that part. So in the citation, we cited them for training and supervision. And then in the alternative to that, we also cited them for the general duty clause that Oregon OSHA has. It is very, very rare for Oregon OSHA to cite the general duty clause. But in this case, we did. We cited them for not taking essentially other means and methods to safely perform the work, such as retrofitting that rock drill, renting or buying another rock drill that would have been safe to use, ensuring that multiple sticks were used so that the person was farther away from the hazard. Yeah, so we did cite that, but that was not the primary citation that we had.
All righty, sir. I do not see any further questions for you. So thank you, Brian Snap, for joining us. Again, Brian Snap, our statewide safety enforcement program manager.
Thank you.
All righty. Thank you. Thank you. And I know we're running up on time here, and I appreciate everyone's dedication to coming in and viewing this webinar and attending, whether you attended both mornings or just this morning. So I do want to respect everybody's time. For just the 5 minutes we do have, please allow me here to bring up a couple of additional tidbits that I had on the agenda. First of all, we touched on this earlier when I mentioned that there was a FACE report. FACE is an acronym that stands for Fatality Assessment and Control Evaluation. It's a national surveillance program administered through NIOSH through grant money to communicate and disseminate workplace fatalities. And we have our own FACE program here that is administered up on the hill at the Oregon Institute of Occupational Health Sciences. So the quickest way to find these Oregon FACE reports is simply a Google search. Just simply Google search, type in Oregon FACE, and it is the very first hit. This was the one that briefly described the fatality that we had back in, 2005 it was, I believe I mentioned it was 2006, where the worker was struck and killed by the rigging that failed. The wire rope under tension came back once that tension was released and struck the individual in the back of the head. He was in the trench shield while the trench shield was being pulled horizontally. Again, legal to do, but that's that work practice that obviously, and as this space summary details, it can be incredibly hazardous. I did mention also on the agenda that we do have a multi-employer guidance document that, yes, comes in the form of a program directive. So Brian showed us where all of our program directives live. We do have a program directive that details the multi-employer workplace citation guidance that our officers can follow, but like all other program directives, these are in the public domain. So we want to be transparent, and we want to assist employers and employees and organizations out there by also providing, in essence, our marching orders. So obviously in the world of construction, but this multi-employer guidance isn't just limited to construction. It can apply to other industries as well, where there are multiple employers represented on the same site. Real quickly, over on the left-hand side, this program directive, which is just a few pages long, defines what we mean by control, what we mean by knowledge, and what we mean by reasonable period. And then it further describes who the exposing, controlling, and creating employers are, and their culpability depending on their knowledge of the hazard and if they have the direct control and supervision or the right to exercise control and supervision over the workers that are or could be exposed to those hazards. So again, it's only a few pages, this multi-employer citation guidance. It is Program Directive 257, and you can easily find that on our website. And if you have any trouble finding anything on our website, you come to me, and I will send you a direct link. Now, for those of you on the call that would like to participate, in some future rulemaking, we are still looking at clarifying reasonable diligence of what we expect employers to have in having knowledge of conditions, hazardous conditions, or the hazard itself, as well as some rulemaking that will better clarify unpreventable employee misconduct. And if you go to our rules page and select where we are providing a little more information on this employer knowledge or employer responsibility rulemaking, it also details how you can be a part of our advisory committee as part of this future rulemaking, or at least take a look at and read the minutes that have been produced from some past meetings. The last public comment was back in October, where it was done virtually. We have not had any public hearings or, I believe, meetings since because of the pandemic, but I do believe that this will eventually be started up again as this year goes on. So if you want more information about our future rulemaking on employer responsibilities and these terms over on the left-hand side that we will attempt to clarify, let me know and I can point you in the right direction. I did also have a couple of mentions on the agenda regarding silica and noise, and I know that had been mentioned already yesterday morning as well as this morning from Rick, Dan, and Matt's presentation, certainly. So over on the left-hand side, I just have a quick list, of course, of what this fairly new silica rule contains, but also to point you in the direction of a number of publications and fact sheets that we offer. And I know our friends up in Washington State at DOSH offer a litany of wonderful publications and guidance documents and fact sheets and hazard alerts, in addition to, of course, to their directives and their rules too, if you work up in the state of Washington. But we do have a handful of publications that do a little better job in providing a summary of what the regulations require when it comes to silica exposure. Now, this is housed in our general industry set of standards, but it does apply to construction work. So even though our silica rule is technically housed in our general industry series of rules, it does apply to construction work, and that is clearly defined right there at the beginning under the scope. We do have a couple of directives that further describe, again, our marching orders, questions we ask, things that we are looking for as it relates to silica exposures, and those program directives are listed at the bottom, both Program Directive 253, which is our emphasis program on silica exposures, and our more comprehensive Program Directive 300, that provides much more detail in how we enforce this silica rule. Noise. Similarly here, noise is housed in our general industry noise exposure standard as well, but it does apply to construction. Now, there's a portal from our Division 3 construction rule on noise that basically brings us back into our general industry requirement for noise. That establishes the permissible exposure limit of 90 decibels over an 8-hour shift, as well as an action level of 85 decibels over an 8-hour shift, when many of these components in the rule must kick in. Hearing conservation program, making hearing protectors available, training, of course, record keeping, things of that nature. Again, we have publications and fact sheets that do a much more user-friendly job in summarizing what 1910-95, the noise exposure rule, requires. Again, our friends up in Washington State have a number of outreach materials and publications also that provide a nice, more aesthetically pleasing summary of what the noise exposure rule up there requires. Real quickly, as we finish up, I did want to give a quick plug to our consultation program. Again, our friends up in Washington have a consultation program as well. OSHA consultation is confidential from enforcement. It is no cost to employers as it's already funded, and instead of citations coming in employers' way, a report of recommendations will come in employers' way. So we are always out there plugging the use of our consultation program. You can find much more information on our consultation program, of course, at our website. Up at the very top of the website, we have a specific link for our consultation program. We have had virtual consultations accomplished over the course of the pandemic. But we're actually getting out there more so these days with our consultants conducting on-site consultations. We can do safety consultations, we can do industrial hygiene consultations, as well as ergonomic consultations. So please keep that in mind. And again, if you're working up in Washington, our friends with Washington DOSH have a fairly robust consultation program as well. And then finally, our enforcement officers can do a little consultation as well, if you will, but we call those pre-job meetings. And the kicker here is where I have that arrow directing you is it must be prior to the work, because obviously if an enforcement officer from the OSHA program shows up and the work has already begun and the employees are exposed to the hazards, then our enforcement officers have to do what they get paid to do, and that's to enforce the rules and potentially substantiate a citation if that is in order. But if a contractor is planning ahead, the work hasn't begun yet, employees are not exposed to any hazards yet, and maybe a consultant has quite a backlog and wouldn't be able to get out there in a quick fashion, then an enforcement officer can actually come out and do what we call a pre-job conference or a pre-job meeting. Now, we do have this mentioned in our field inspection reference manual, which is basically our whole set of marching orders, which is available on our website. Easiest way to find our firm is go to the A to Z index, topic index, and look for F for firm, our field inspection reference manual, and that's where you'll find this short and sweet paragraph that details what our enforcement officers can do in terms of a little consulting. No citation book, no pictures needing to be taken if it's truly a pre-job meeting and the employees haven't been exposed to any hazards yet. So I truly encourage the use of pre-job meetings. Get our enforcement officers out there in a little more of a consulting mode. They tend to like that a little bit. It's a nice change of pace. And I have a few minutes after 12. I kept you too long. Thank you to our presenters. Thank you to the West Coast chapter of the Association of Drilled Shaft Contractors, otherwise known as the International Association of Foundation Drilling. Rick and Dan and Matt and Becky, holy moly, thank you so much. Thank you to all of you who have asked questions, and certainly thank you all for attending. And please keep in touch with us. Thank you so much for attending this webinar. We will make this available, and I will send out some notices to the folks I sent the invites to make you all knowledgeable on when it's posted and when this material and when the recordings will be posted. Thank you all for attending. Appreciate it. We'll do this again.
Thank you, Craig.
Thank you, Rick. Thank you, everybody. Thanks.
Bye.
Thank you, Chris. Thanks for all your help.
Oh yeah, glad to help. Thank you.